All right, welcome back. We are COMP397 in the winter 2021 semester, and it is week 12. Wow, things really progress fast. Part one of our broadcast might be the only part. Let's talk about this in a sec. First of all, I wanted to welcome you back. I know it was kind of a little bit of a longer weekend for some, definitely for me. I was planning to do some more recordings. That did not happen. I'm sorry about that. But it's the long weekend, and people are just like you. I was a little bit enjoying the good weather and having a chance to rest a bit. So last week we talked about multiplayer networking, and there was no lab. This week we're talking about lab 11. We're going to talk about how to simplify animation, convert our project to the universal render pipeline, which I'll show you how to do. We're going to create a shader with shader graph, custom shader. I'll talk about how to do that, as well as we'll test everything on the emulator and on a native device, which is something I can show you as well. So that's what we're going to be doing this week. What's due? Assignment 2, part 2 is due tonight at midnight. So for some of you who haven't got that done, all the requirements for assignment 2, part 2 are due tonight at midnight. Lab 11, that's going to be due Saturday at midnight, this Saturday. But where are we sitting? We're sitting here, and next week is the final presentations. So I kind of talked about what's in the final presentations. It's in the documentation, but we should probably talk about that again before we progress. So I just wanted to bring that up. First things first, let's talk about that piece, because next week, when we get together, that is kind of like your final piece, as well as the stuff that's due. So I just wanted to just briefly bring it up one more time, just as a reminder, because I know I talked about it last week, but I also wanted to talk about it again. So again, remember that next week, so let's look at assignment 2, part 3 first. So assignment 2, part 3, this is due exactly what it says. The final version is due Friday, April 16th, 2021 at midnight. And even though it's, remember what's happening next week is, this is when your final release is due. So everything that is due for your final game is due next week at midnight, next Friday at midnight. Okay, so there's no extensions past this date. This is the day that everything's due. It's worth 20% of your final grade. So it's a little bit more, and everything that is supposed to be here, I talked about last time, should be included. Okay, so just a reminder about that. Then you're also going to be doing a video presentation, also due the last day of class, worth 15%. So between the two of them, 20 and 15 is 35% of your final grade. I just wanted to remind you about these two things that are both due next week. Okay, so what that means is, if we look at our schedule, what's due, this part, sure, assignment 2, part 2 is due tonight, but one of the things to note, and I'm going to add this in so you can see it, assignment 2, part 3 is due next Friday at midnight, and that is the last day of class. If we look at the schedule in our calendars, this Friday is the second last Friday of class. Next Friday is the last Friday of class. So that is when assignment 2, part 3 is due. Make sure you sign up for group 2. The other thing that's due, and again, that's why I'm recording this, just from, I wanted to make sure we are on track, is the final presentation. So final presentation, also due next Friday at midnight. So both those two parts. Now, people have asked for a couple of things here when it comes to the final presentation and for the assignment 2, part 3. One thing they've asked me is, well, what's the difference, Tom, between the video that we make for assignment 2, part 3, which is the release video, and the video that we're going to make for our final presentation? They're very different. Okay, so let me go through those pieces, just answer the questions, because that's some of the questions I was asked throughout the week. By the way, there wasn't a lot of questions this week, just some, and those are the two of them, right? So let's go into that one. So if I bring up assignment 2, part 3 one more time, and I go to that video requirement, this video requirement, which is the demo video, is like every other video requirement. But basically what you're going to be doing is you're going to be demonstrating your game screens on the device simulator. And what I want you to talk about whenever you do a video like this, and please give me a link, not a video, that you upload to eCentennial, please, you talk about the code. You talk about how your game and that kind of stuff. That's what you talk about here, all right, in the short video. That's very different than the final presentation, which is totally different. That is, there's a couple parts. One part is your presentation slide deck. The presentation slide deck is worth 70% of your grade for the final presentation. That means like you need to have a slide deck that you talk over. You're gonna speak over this thing, and then there's a game demo that you're going to insert or embed, or I don't know, start talking about your game demo. Some people say, well, can I use my game demo from my assignment 2 part 3? That's different. The game demo from assignment 2 part 3 it's really not a game demo. It's more like, here's my game, it works, and here are the parts that I need for my final release. That's what that part is. What this part is make it work, demonstrate every part of your game, right? All the piece parts for your common requirements as well as your game type specific requirements. Most of you are doing a 3D platformer with some effect, right, which is good. And that's what you're going to be demoing here. All right, so I'm not expecting you to insert the video. Please do not insert the video from assignment 2 part 3. That is a different thing, and there's different reasons for it. So you're making 2 videos for next week, one for your release and the other one for your final presentation. Your final presentation is critical. If you don't have a video for your final presentation, you will lose 30 marks as an example. Again, one thing that we've changed for this semester because of COVID and the way we're running the course this semester is there is no live presentations. There are no live presentations. That means, one, the best person who is, the best presenter from your team, they're the people that I'm expecting to present. Okay, so it's not something that I'm expecting from that everybody in the group has to present. It's not required. Just one person, the best person from your group. As long as they present and they go over the slide deck for this thing, then they're good to go. Okay, I can't urge you enough to please read the documentation. I will remind you of this next week on Monday. So what are we doing Monday next week? That's the thing, right? So if you look at the schedule, Monday is supposed to be final presentation week. I'm not going to do a formal lecture or recording next week on Monday. Instead, I'm going to leave it to office hours, any kind of marking hiccups, because I'm planning to do a pile of marking that I have to do for you guys for this weekend. So I'm looking at doing some feedback, anything that's missing. If you have a question about anything in the course, that is what next week is for. Not just Monday, but Friday as well, the last Friday of the week. I'm not going to go through your presentation or that kind of stuff with you. So there is no formal class planned for next week. There are no labs anymore past this lab, so we're not going to do lab 12. There's no lab. It's only up to lab 11. So please make sure that you get this one done, because you're going to be graded on the best 10 out of the 11 labs, all right, that you're going to be doing, or something like that, barring that one of them was a bonus lab. So probably the best 9 out of 11 labs is what I'm probably going to do, right? Just to make sure that you've done it. If you've never handed a lab in, that would be bad. You want to try and make sure that you at least have these, because they're each worth 2% of your grade for a total of 20. All right. So if there's only 9 that I'm ranking you on, that means they're going to be slightly more than 2%. Okay. So 2 point something. So please make sure you at least do this one. Okay. Each one counts. Some people have also asked for extending times on some of the requirements. So they're saying things like, Tom, can you please give me more time? There's no more time. I can't give you more time in the course. So whatever you've got happening, it's due next week. Everything that, if you've done it or not done it, everything is due, worst case scenario, next week. Okay, so please make sure you get it in by Friday. No extensions, because next Friday is like the last day of class for us, period. All right, so so please make sure you get that done. And it's the last week to get together with your team and all that kind of stuff. There's been some great things I've seen this semester already, and there's been some stuff that's not so great, but that's just like every semester. So do your best. I believe in you guys. I think you guys can get it done. If you need me for technical help throughout the week this week, this is the week to get that help. I will be available for you guys so I can answer your questions as this wraps out our week, this week and next week. All right, so any kind of technical things you need this week and next week, I'll be around to assist you. Please do not wait till the last minute and to tell me that you can't build something or something's not working the way you expected it or you couldn't get this done or whatever. Please hit me as early as possible and I'll try and help you one-on-one or have a meeting with you guys on Discord. Okay, so please let's do that this week and next week. And then we'll wrap it up nicely and hopefully you guys are going to go away with a nice little game that is available on mobile and potentially on WebGL. All right, so that is my spiel on week 12 and week 13. Those are the last 2 weeks of class. Then we have a bit of a break, and then the summer semester starts on May 10th for those people who are participating in the summer semester. So hopefully you'll have a chance to sign up for courses on that as well. Okay, so that is the schedule. What are we talking about today? We're going to start talking about the universal render pipeline, which is something I want to discuss with you guys today. But before we get there, let's bring up our lab. So that is a lab 11, but I've asked you guys to download some starter code from last week, which is lab 10A. Let's do that. So I'm going to download the code. And this is going to go on the downloads site. And as you can tell, it's quite large, right, in terms of how much I'm downloading. Because remember, we have up until now, animations, different things going on that's making this download a lot bigger than normal. We're going to try and optimize some of this today because I'd like you to try and have the smallest download you can. Okay, so I'm just going to do this offline here. I'm just going to cut this one and put it on the desktop. Guys, please stop me if you need help for this one because I want to help you guys out as much as possible. All right, so here's our download stuff. We've got all the different lessons here that we've done together, and this is 10A. I'm just going to unzip this, so just like you would. So let's unzip this, and this is going to bring us until we are. Let's refresh. So this is called. This will be 11A, and we'll move this away from main. And this won't be 11A, this will be lesson 11A, not lab 11. That's what we normally do. Lesson 11A. There we go. And that's going to be our starter. I'm just going to redo the this file here. So it says week or lesson 11A. You can use my favorite editor for that. You can use whatever editor you like to use for this one, but that's what I'd like to do. I use Visual Studio Code. And now we're going to add it to our Unity Hub. One thing to know for those people who are interested is Unity Hub is updated, and the latest version of Unity 2021 is now officially out. So notice in my installs, I have already downloaded and installed Unity 2021. So if you're interested, if you're a gaming student or someone who's going to continue with the stuff, in future projects, we'll be using 2021.1.1F1 or onwards. Right now, though, we're still sticking with 2020.2. So please, this is the one that I've been using this whole time. Please do not give me 2021. It will not probably, some of it may not work the same way you think it will. So I'm going to add that new structure. So it's going to be on the desktop. We're going to go to Centennial, and we're going to go into week 11A and select that one. And now I'm going to start this one off just like normal. So if you give me a second, it's going to pull it up, and we're going to go from there. And it's just loading up on my side. You guys just can't see it. It's right here. All right, here we are. So this is where we were last time, and I'm bringing this up this time. I'm going to go into my scenes where it is the start scene. Sorry, the main scene. I'll be okay. Let's go into the main scene there. So one thing it tells me, do I want to import TMP Essentials? Of course, I always do. And the way we have it is it's procedurally generated now. So when I run it, it will procedurally generate my scene, my world. It will create 2 enemies or more for me. There they are. There are the enemies. But one of the things that we have, and this is what we have right now, a couple things. We're able to see this. Let's stop this and let's go to layers and turn off our enemy marker. I don't want to see those right now. A little bit annoying. Let's try that again. Again, remember it's procedurally generated. So what we get is, what I mean by that is it's random, okay, more than anything else. And you've got your little enemy there, and he's waiting for us. Okay, that's what he's doing. All right, that's pretty good. And what I want to do is talk about a couple of things right now. So one thing we have under scenes is we have this main area, and let's get rid of this extra folder, just delete it. One thing I have is main, and under lighting, I don't have lighting settings. Let's add some lighting settings for main, and I'll talk about how to do that. Notice it says there's an area here that we're going to talk about first called new lighting settings. Let's do that first before we go do URP. So if I click this, it's going to add a new lighting settings asset, right? We'll call this main lighting. Main lighting goes there. And what you can do with it is you can decide whether you want to use real-time illumination and a bunch of other little settings just for lighting. So if I go back to my scene where I have my level, it will be generated differently. What I want is definitely to do auto generation of the scene, of the lighting. It's going to make our lighting a little bit lighter, brighter in the scene as well, which is good. You can add things like ambient occlusion and the type of lighting you want. You can also choose things like your environment. I'm using my default skybox, but instead of my default skybox, what I want to do is use my skybox material. And what I'm going to do here is I'm going to create a new skybox material in here, which is going to be procedurally generated. So again, under materials, I'm going to right click and I'm going to add in a new material. I'm going to call this skybox material. And I'm going to go to the inspector, and under skybox material, I'm going to choose between this one, I'm going to go to skybox, and I'm going to choose procedural. And so this gives me the sky tint and the ground and the sun size and all that kind of really cool stuff. But in order for me to see this in my lighting panel, by the way, you can get your lighting panel by going to window. And if I go to so rendering, there's a lighting, and there's also Light Explorer. So Light Explorer is this one. Window, rendering, lighting is this one. Okay, it's all this. So I'll give you this little thing. And what I want is for me to drag and drop my skybox material in there. So drag it up in, which is going to give me a different effect than what I have already, right? Why? Now that I've got my skybox material inside of my lighting, right? That's what's going to happen. I can add fog to my scene as well, which is something that's going to help me with generating stuff, right? And the density of the fog and the distance and all that kind of stuff is important. So if I run this now, let's take a look and see what I have, right? And if I go to my scene, you're going to see a couple of things here, right, that are different. One is it's going to appear brighter, a lot brighter, all right? Why? Because we've added a lighting object. And then further down, what we want to see is some kind of fog effect that takes effect in our scene. For that, we need to go into scenes and go into the main lighting. Here's our main lighting. And where it says, you know, the the baked global illumination is one thing. We're using a progressive CPU. That's an option. And the reason for this is because I don't want to use the GPU. GPU is more of a preview. And also to use the GPU on a mobile device may not be the best thing to do. So that's the first part. So just getting our lighting right. And this is in prep for what we're doing next, which is going to be our URP. I'm going to talk about this. You can add ambient occlusion in there, and you can add in the distance that you want your ambient occlusion to be in there, but this is going to be changed later. So let's just leave that unchecked for now. All right. But more or less, it talks about the direct samples, how light map settings work, and so on. You're going to have a lighting setting, and there's a bunch of stuff here. There's the scene lighting, which is exactly what we just saw. There's the environment lighting, which is the skybox. Here's your skybox. The source of the skybox. The sun source is the directional light. That's one thing we have, right? And then you have your fog, right? And your density. If you increase your density, so if I go to like 0.1, you can see that there's a lot of fog in the scene with 0.1. Too much fog in the scene. Instead, what you want to go with is something like 0.03 or something like that. And what that means is like things farther away are going to be in fog. And fog actually it helps, it doesn't hurt, because it means that part of our scene is not going to be rendered in higher resolution. And that's going to be more performant for us on a mobile device than if we're using if we're not using fog. So that's one thing we want to turn on. If I stop the scene, it goes back to 0.01. Let's put this to 0.03. So this is the fog effect under the environment panel in the lighting panel. Environment tab, lighting panel. There's also real-time light maps. If we had something there, it would appear here. Baked light maps would also appear here. We don't have any of those things in play right now, so none of those two things have anything inside of them. But we do have things in environment, and we do have things in scene. Let's modify our in the environment. We can see if we go to skybox, this skybox right now, notice this is the preview of the skybox. Okay, so if you actually look here, it's a procedural skybox. That's what I've chosen, and it's high quality. You can choose different ones. You can increase the sun size. So take a look. If I kind of click down here in the preview, you can change the sun size. So I can make the sun size bigger, okay, relative to what it looks like in the game. Sun size convergence and atmospheric thickness. What this does is if I increase this value, it gives me kind of like this on the horizon, more of this yellowish color. And you can see it immediately happening here in the scene. And what it is when the sun is on the horizon, it gives us that like thicker horizon, kind of color that makes it look more of a summer scene. I can increase the exposure. I can change the sky tint if I want to, as well as the ground. I can make it much darker instead of this color. I'm going to leave everything the way it is. My sun size convergence, if I increase that, be careful, it actually changes the way things look in the scene. Now, if I run it now with the new settings that I just made with my procedural skybox, you can see that we have this area here that is much kind of brighter in the corners. If I go to the scene now, that's what you're actually seeing. You're seeing your fog over here. What would this look like to the player? Well, if you look at your simulator, for the player, it's not going to really make a huge difference that they can see. We can still see far away objects, way far away here in the game, but what you want to do is maybe even increase fog a little bit more. So let's just do that. So going back to lighting, I'm going to go back to my environment and increase fog to 0.04, 0.04. Again, the higher the value, the more fog is going to show up on your screen. A lot faster, but there's going to be a limit. You can also change the fog color. So example, I can make it black or some other color, a lot denser. And also how much of the fog is transparent. Right now it's fully opaque. You can also make it so that the fog is semi-transparent, but actually that will reduce your performance, not increase it. So be careful about that. Let's play this one more time and see the difference. So that's 0.04 now. 0.04, I'm not seeing these far away. It's hard to see in the game, but what I want to show you is if you zoom in now, these characters that are farther away are still difficult to see, but I can still see them. Let's go with a little bit more. So 0.05. Again, let's try that again. And if you run it, the idea is you want to make it so that far away stuff is in fog. You don't want to see details back in here. The other thing that you can also do is play around with your camera settings for your player. So remember, it's all performance stuff. So under player, you want to go to your player cam. And right now, under your player cam, under the inspector, you can see that I have 1,000-foot distance. So, 1,000 meters. So 0.3 is the near plane. That's how close I can see stuff. And 1,000 is the far plane. I may not need 1,000, right? And let's chop that in half for now to show you the difference. So here's 500, and let's run the game again. The shorter this plane is, as an example, then the less I'm able to see. But you can see that I can still see these faraway objects out there, even with 500. What if I reduce this to like 100? Well, then that cuts down some of the objects way far away, but still I'm able to see some things. What if I go to 50? Well, now I can't see those background objects at all. You can see that right away. 50 might be a little bit too much. I recommend let's keep it to 100, and that would be your setting. So you can see some faraway objects, but nothing too far away, and anything beyond that is actually going to be fog anyway. All right, so that is what I recommend. Let's move this to 100. So why am I doing this? I want to optimize for mobile. That's what we're doing. Okay, we're optimizing before I move into URP. So that's number one. So now if I run it one more time, you can see that I can still see stuff. Right, here is my, and again, I've got a kind of a partial screen going on here. So, there's certain things I can see and certain things I can't see. And sorry, whenever I'm in the simulator, it's really fast compared to what it looks like on the emulator. But I'm going to try and kind of maneuver as you get closer. You can see that there's so far away objects are kind of gray. You can see a shape, but you can't resolve what that shape is until you get a lot closer. Once you start getting a lot closer now, you're going to be starting to see that shape coming into focus, right? And what this does for me is it makes it so it's more performant, not necessarily more playable. And we can see now we're really close up. You can see that there's, I can see the character quite closely, right? One thing to note is we want to be able to resolve what this character looks like. So if there's any kind of weird, funky effects, right, or anything like that, like for example, he looks like he's almost transparent now. Take a look at that, right? Almost transparent. Almost looks like he is like in a weird transparency. And that is a result of some of my settings. So be careful when you do that kind of stuff, right? It's also the result of his materials that I've put in. So make sure that his materials are opaque, not transparent. We're going to get back to that in a second. So let's modify those now. So that is under in my enemies. And if you look at my resources prefabs folder, in my enemies under crypto, right, as an example, you have keep crypto points to a bunch of materials. So this is, again, I wanted to point this out to you so you know where I'm looking for stuff, right? Crypto, remember, it has a nav mesh agent, but meanwhile, he's being rendered somehow. If I double click on the prefab, it brings me into prefab view mode, right? And in prefab view mode, I'm able to see a couple of additional things, right? CH45 is the actual object, and it has a bunch of materials. Here's the crypto material. And if I look at the crypto material, you can see now what's happening. So I've got my metallic and my albedo, and here's my emissive color, which I've got turned on, right? But under my albedo, if I look there, somehow I'm getting a transparency. So why is that? Right, because that's the main issue. That's why I'm getting a weird kind of transparent look effect. Somewhere in here, whether it's albedo or whatever, we're getting a transparency happening, and that is what's causing that weird effect. Our HDR is also semi-transparent, and we want to make that. So, no, sorry, this is fully opaque, right? That's our emissive color, right? So that's what it should be here. It's using RGB values from 0 to 55. You can also use HSV values if you want to, but really what this part is just how much emissive properties does this thing have. And this is kind of an example of what you're seeing down here. Okay, this is what you're seeing here. So you're seeing a real-time example of his texture is what you're seeing. Okay, so that's that part, but the thing that's tricky is this part, rendering mode. You want to change this to, instead of transparent, you want to change this to opaque. And that's probably what did it for us. So that was kind of a bug that we had. And when we look at it again, we shouldn't see that happening anymore. Just going to go closer. Again, this is all procedurally generated, so the path will be slightly different every single time. And there he is. So now you can see we're not seeing completely transparent. Let's take a look at what these guys look like. And that's what we want. So they're not transparent anymore. All right, that's good. Because some people were saying to me before, they're like, I don't know why, but I'm getting these really weird transparencies. And that's my fault. That's just something that I had put in there. So they look a little better now anyway. I just want to bring it this close so I can see it. Okay, good. So now that I've messed with this, let's also push this to the device like we've done a bunch of times before. I'm just going to go back out to the level, save the level. So save the scene, file, save project, right? And then what I want to do is I want to go to build settings, which is right here. And I want to switch to Android, because that is something that we're switching to. So we're switching away from PC, Mac, and Linux build to Android. So switch. Again, this takes all the time that we're talking about, and I want to do all this first with you before we go on. So all the little optimizations we can do. And I'm just going to wait for this to be done. One thing also to note is that we have extra animations, and I'll talk about those in a second. There's my Light Explorer, by the way. Light Explorer basically shows light probes and static emissives in the scene. We don't have any of those. All right, so we've switched over. One thing to note is you should have at least, if you're running a device like me, I'm running an actual Samsung Galaxy S7. That's what this is. But we should see the emulator. I'm going to pull up LD Player for that. So here is LD Player in a second. There it is, coming up. Again, I think LD Player is probably the way to go on some of this stuff. Okay, so that is LD Player. And then what we should probably do is also bring up my other device. Just a moment here while I make this a little bit smaller. So this is this. I'm also using the other app that I was talking about before, which is Visor. So here's my Visor app, wherever that is hiding right now. Where is that hiding? On my screen. Okay, but Visor, what it does, remember, it runs on my phone. So it actually shows you what it looks like on my phone as opposed to this. Why is that weird? Let's see if we can move Visor. I don't like that. Let's just close that down. Let's try it again. It's really bizarre. It's pulling up, but it's pulling up something like behind something else. Let's see where it is. Bear with me while I fix this problem. It's not there. I love it. It's always a million things that I got on my screen going on. Oh, isn't that interesting? It's like it's appearing off screen for me or something, which is not optimal, but it's okay. Again, no, don't totally need it, but it'd be nice if I could see Visor as we go forward. So let me close some of these down because it's probably going to take up cycles for me. Yeah, I don't know why. That's a first today, but it's okay because we're going to push to our emulator for now. All right, so this is what I want to do. And let's push to the emulator. So what this means is I should see any compatible devices here, right? So the emulator should come up. A lot of times what we want to do is refresh if it's not showing up. So it'll pull up any devices that are here. Now you can see that I have my emulator. If it wasn't showing up before, that's my target. And I want to do a build and run to test this, what it looks like in the emulator. Let's do a build and run. And we'll build it in the folder. builds. And we'll call this Android as before. Wonderful. Okay. So make sure that I got everything going on, and we'll be there in a second. Just waiting for this to come up. So this is doing the build, and if I spark out a little bit, and that means that if I am a little bit behind or laggy, please bear with me as I'm building. And if you're watching the YouTube video, please skip ahead. So we're going to talk about animations after this. So let's just do that while this is transferring everything over. Again, really weird that that didn't do that at all. I'm not sure where that package is showing up, but somewhere off screen, that's for sure. And I can't seem to move it, which is weird, right? Because normally I can move it around here like in any other app. If I wanted to move an app around, then I can do it just by clicking on it. But isn't that weird? Yeah, it is what it is, my friends. All right, it's almost done. And we're good. So now I should have deployed to this, and there we go. So this is what it should look like, or a close approximation of what it should look like in-game, right? You can see again that you have some of that fog effect that we put in place. We still see this that comes up nice, and very nice in terms of the way it works. What we want to do now is we want to check to see, can we see the animations before we move on to the next step? Because that's kind of the thing we want to do. And I just want to move this ahead at the same time so you can get by that little block there. And so far we've been able to avoid being attacked randomly, but we should be able to see, what I really want to see here is what these guys look like before we're kicked out into oblivion. He's quite shiny, right? If you notice what he looks like right now. Again, what I could always do is pause the game. So that's something that I could do. Remember that it unpauses when I bring it back up. And there is this little bit of a window that comes up so that just even if it's really hard to see, we can see this guy. So that's what he looks like. I can't move around when I'm paused, but I can move around when I'm not paused. So we can take a look at some of his, the quality of the skin that we have here. We're going to get into this later on as we move and transfer this out of this mode. Okay, that's great. So we know it transfers the device nicely and everything's okay, but we have a bunch of animations. And remember what we did last time? We brought all these animations into play. No one said anything. It's not like, Tom, do we need all these animations? And the answer is you don't. Okay, so let me explain what you need and what you don't need. So this is step one of our lab. And what I want to do is I want to remove some of these animations, and then we'll put this up on GitHub in a second. So what are these animations I speak about? Well, there's a standing melee kick. All right, so this is the one. Notice that there is a standing melee kick. It looks like a little clip. Remember? In our animator, right, which is the animator for our enemy. So there's our enemy. The enemy has an animator that I'm using, right? Each enemy has its own animator, right? So that's something to note. Sorry, let's go back to not the enemy, but crypto. Crypto has its own animator. It looks like this, and crypto uses a couple things. I use a idle clip, a jump clip, and a standing melee kick, as well as a running kick. But I need to use all those things, right, from, if you notice, there is in animations, there's all this stuff. Well, what I can do instead is if I open up these packages, right, and if right now I do kind of I look at the clip, here's the clip here, and I have the entire character, and I can preview the clip, what it's going to look like on the scene, right? Okay, but what if I don't need all of this information, just the clip? So I can Control D, right? So I click on the clip and I press Control D to duplicate. There it is. There's the clip, right? And so that is the animation right there. And I can do the same thing for the other one. So I can go into each one. So I can go into my running, Control D, copy that one. And jumping 2, I have 2 of them, right? Jump 2, Control D, and then also jump 1, Control D. So I'm just copying them all, as well as idle, Control D, and finally hit, Control D, and then death. We have lots of little animations here, Control D, right? So these are all the animations we got: death, hit, idle, jump, jump 2, running, and standing melee kick. All right. So these are all the ones we have, right? That we have in place. So we have all of these ones. And if you notice right now, if I go to jump has an animation. If I click onto it, it goes here. But what I can do is, instead of jump 2 using this one, I can drag and drop my own. So I can take this one and drag and drop it in there, right? Yay, that's nice. And I can do the same thing for the other one. So I can go to standing melee kick. It'll point to the one in here, but I don't want this one. I want this one right here, the copy that I made. Okay. And same thing with running. So here's my running animation, right? Notice it says loop time, and that's because I copied it from loop time. But if I click running now again, and if I click onto it, it shows me it's this one. I just want to replace it with this one, the one on the outside that I made a copy of, right? And finally, idle. Idle, it shows me this one, but I don't want that one. I want this one right here. The rest I never really used, so I'm going to leave them as is. But what I can do now is I can delete all of this information other than T-pose, keep T-pose. But the rest, death, hit, idle, jump 2, running, and standing melee kick, these animations, right click and delete them, please. And it's going to say, are you sure you want to delete them? Yes, I do. Remember, we have copies anyway. So does this still work, even though I have the other ones? Well, the thing to check is there a clip for each animation? And there is, right? So we still have a clip for each animation. We're all good. And if I press play, you're going to see that there's absolutely no difference between one and the other. You're still going to see this this guy here. But what we want is for this guy right here to react in the same way. And you can see I've got the same animations, even though I got rid of the actual whole animation themselves. So I got rid of all that stuff, which is pretty cool. So somehow it still works. Well, of course it works, because if you actually look at this, the death animation itself, if I bring it up, you can see now that if I was to run this thing, it's still running, but there's no model that's available for preview, right? We don't have a preview model for the death animation, but it's still going to work, right? It's still going to work. I can choose the Unity model instead. So what the Unity model is, it gives a bit of a preview, and it gives us this little guy here who is it's kind of like an avatar that we can see, so we can try it out. What is this death animation going to look like, as an example, if it's going to work, if there's a death animation at all. Like if you go to auto, it's not going to show anything. And I can also choose other models, so I can always choose my T-pose model that I want to use there. And now you can see that it's actually going to take effect. So there he is. Okay, so that's pretty cool. And I can do the same for the other one. So I can say death, hit, running, jumping, and melee kick, right? As an example, I can do the same for all these. So you see hit is pretty good. Jump, jumping 2, running. Once I've done one, I've done them all. And now you can see what it looks like, even though I don't have the original animations in place at all. This is a great place to put it up on GitHub. Control S and File, Save Project. Let's close this down. And now I want to do an exercise with you really quickly. So you can see why I did this craziness. Why did I bother going through that whole detail and blah, blah, blah? Well, if I back up and I take a look at the size of this document here, so properties, this is including the build. Including the build, it's 1.09 gigs, okay? This is the previous, last week's. Okay, I didn't add anything, I actually removed stuff, right? So if I go to properties, you can see that this is 1.4 gigs. So I've actually saved myself, 300 megabytes just by getting rid of those animations, right? So the other thing to do is if we remove the size of the build right now is something like 42 megabytes, right? That's also something to look at. You can see that my build for this one is 43 megabytes. Okay, well, what about the build for the last one? All right, so let's take a look at that one. So if I go to build for the previous version, it's also 42 megabytes. It hasn't affected anything, but the size of my entire project. So what happens is, one thing I also have to point out is this: Unity optimizes. There's several optimization steps that go on the background with Unity. So whether you have massive models or whatever, the only thing that's going to be rendered are the things that need to be rendered. And for the most part, Unity does a great job of improving the build. So 42 megabytes as an example, or 43 megabytes for the new one, for a package is quite reasonable, for what we've been doing here. Okay. All right, so that's number one. Let's put this up on GitHub now. So again, I'm going to do command prompt to do this. So I got my command prompt here, and I'm just going to drag and drop. I'm going to say cd space. I'm going to drag and drop my less than 11.8 over there, right? And we're going to do that. And we're going to say git init, git add dot, git commit -m when it feels like doing its thing, initial commit. These are all things you should know about by now. I'm going to clear the screen. And what I want to do here is I want to connect on GitHub. So let's do that next. So we'll go up online. And we'll make a new repository as always. So new repository, we'll make it public. We'll call this COMP397 in the winter 2021 semester. And it is, again, what did I call it before? Sorry, one more. Let me just look at that one more time. Oh, yeah. So that was weird. I did kind of different things there. Doesn't really matter. I'm going to call it Lab 11A. Okay, just to be clear. All right, so that's kind of what I'm going to do. Let's do that again. Doesn't matter. At the end of the day, you'll have a final. Right? So COMP397 in the winter 2021 semester, and it's Lab 11A. It's public. It has the same stuff as here, and we'll grab all these last 3 lines of code, copy them, and go to my command prompt and right-click, which will allow me to push this up on GitHub. And this is the way I've been showing every single time. Notice when I push up on GitHub, I'm not pushing up a zip file. Some people, for whatever reason, are pushing up a zip archive up on GitHub. That, guys, you will lose marks for that kind of stuff, right? All right, one more thing it does is it goes, okay, well, look, large files detected. You may want to try get large file support storage for this file, which is 70 megs. Really, it doesn't require until you go over 100 megs. Just letting you know about this. And so be careful. You can actually add large file support, but when you do so, it is not free. You have some free amount. I think you have 1 gigabyte free large file support. Beyond that, you have to pay. So again, be careful about this when it comes to large file support. You can turn large file support on for larger files greater than 100 megabytes by looking at, let me just refresh this thing so you can see it now, and I'm going to grab this and put it inside of our thing here under GitHub repos. I'm just going to make this, just like we've done before, into Lab 11 final, so you have a reference for yourself, so you can kind of follow along, and you can compare my code to your code just in case you need to. Wonderful. All right. But what I meant was, if you go to GitHub large file support, right? So large file support, it'll take you to git-lfs.github.com, which brings you to this, Git large file support. And it talks about what it does. All right. So there's something called large file storage, which is kind of interesting. It's a separate download for Git and locally in GitHub. So something like a large Photoshop file, which is what a PSD file is, you can still store something that's quite large online if you'd like to, but you have a limit. What it goes to is in a separate spot that you don't see. There is a archive that it stores different files like this, big files, right? And you can add it on. You need to create something called a Git attributes file, and the Git attributes file includes anything that is supposed to be added as a large file. So please follow this example if you need to. And for animation sometimes, or some larger files you download from your assets, your Unity assets, then sometimes they're quite large, and it'll trigger large file support or storage warnings. Okay, so that's one thing. So I'm just going to grab this link here, and I'll put that in on our site as well, under the lecture piece, just in case you need to have that link. If you're interested in downloading stuff, I've already done so because I ran into some issues, before I did this exercise. And so this is Git LFS download and install. Again, optional. I don't expect you guys to do this at all. This is only if you need LFS support. If you do, then great. It's right here. You follow the instructions on the repository site, and it talks about how to do it, and it explains everything about it, what it does, what it costs, and the whole thing. It's all in here if you're interested. I'm not going to cover that because it's a little bit out of scope of what I'm doing in the course, but just in case you run into that when you're uploading stuff to GitHub, you'll see that sometimes you want to support that. All right, let's move on. So that is that piece. Now I want to relaunch my project. Now that I put it up on GitHub, let's launch my project again and continue. And I'm just going to wait for a second while this loads. And here we go. Okay, great. So this is where we were last when we left off. Now we want to talk about making our own shader. And remember what a shader is? There's a difference between a shader and a material. Shader is the way we tell the game engine, Unity, how to render objects in the scene and to create realistic scenes that look like they're lit. Remember in our on the course shell that what it talks about is with lighting. Lighting isn't real. What lighting is an approximation of what it looks like in the real world when light is being cast on objects. And things like reflections and shadows and all those kind of things, there's a lot of little math tricks and formula calculations that's being used to produce a scene that is realistic and that increases immersion for the player. And we use kind of mathematics to do that. Well, what we have is sometimes we want to create our own shader, and the shader connects to a material. So if I go back to Unity, and if I look at some of the materials we have already, so let's look at our scene. Right now it's looking empty because remember it's procedurally generated. But in our scene, we have a material folder, and inside there, or in our assets, and if I look on the right here in the inspector, if I look at any one of these things, let's say, for example, crypto, which is our enemy, you'll see that it has a couple of things here for the material. One thing is the material name, crypto. And then we have the shader. The shader is a little program that tells Unity how to respond to light sources in the scene, for example, our directional light and ambient light sources, and how this material responds to the light in the scene, whether it's reflective or refractive. Does it have a normal map that makes it look like it is, has more texture, as an example than before, and so on. And remember the difference between a normal map and a regular texture, an albedo texture. A normal map basically does not change the geometry of your of the image that's being applied to your mesh, to your three-dimensional object. It doesn't do that. What it does is it changes the way the light appears to bounce off certain vertices based on the map that we're giving it, the information we're giving it here, the normal map. Okay, and usually there's a mapping, a one-to-one mapping between the normal texture, this thing here, as well as here's the normal map texture. This is what it looks like. The normal map texture, as well as the, and I'm spraying up here, this is what it actually looks like in a program, right? And all it is the actual texture has been unwrapped, and light and dark areas have been highlighted. And so what's happened is it's going to, it takes this normal map and combines it with the diffuse texture, which is your normal texture, and then it comes up with a different effect. That's what it does, right? And so it's a trick. That's what this is. So this is the diffuse texture. It looks like this. Diffuse is just unlit, right? As an example. And we also have other textures for specular. Where do we want the specular highlights is what specular is, as well as glossiness, and our emissive, where we want to specify which part of the object we want to be emissive, and so on. So some interesting information here for our object. But in order for us to test this, we're using a main. And instead of making a main, what I like to always do when I'm ever testing anything is I'm going to create a test scene. So let's do that together now. So I want to make a brand new scene. So I'm going to go here, create new scene, and it's going to help us with testing. We're going to call this test scene. I recommend this actually for all your builds, whether you're using doing Unity directly, or even if you're doing a native Android app or iOS application, you want a test scene or view, if you will. And the reason for this is this way you can mess around in the scene and it won't affect your application. So it'll give you a chance to, kind of use this as a place that won't potentially affect other things. So in a test scene, we don't have anything in here. We have a main camera and a directional light. But what I want in the main test scene, or in the test scene, is another, I'm just going to add a ground. So I'm going to create a new 3D object, cube. There's our cube. And in my cube, I'm going to call this the ground. And I'm going to change the scale of everything that I have here. So right now, my scale for my cube is 111. But I'm going to make it so that the Y scale across the Y-axis, which is up and down, is like 0.1. Make a ground not completely flat like a plane, but actually a little bit higher than that. Awesome. That's what I want to see there. And I want to change these values to like something like 15 and 15. So kind of give me a sense of what the ground plane would look like, right? This is what it's going to look like now. I also don't have a ground texture, or material, but I'm going to add that in later. I have a ground maybe that we're going to add in later on. The other thing is the main camera right now. What it does, if you click onto the main camera, and let's click gizmos on so we can see where that is. The main camera is like way over here, and that's not good. That main camera and ground are separate. Let's make sure the ground is at the 0, 0, 0 mark. So I'll put these at 0 and 0 and 0. And we'll put that back. And then when the main camera is in play, we can see now that we can see the ground. And yours might be a different value. I want to move the main camera so that it's kind of on the corner to make it a little bit more of an interesting scene as opposed to straight on. So what I'm going to do here is I'm just going to grab. Now, one thing you can do is you can always grab the arrows, but you can always grab the. I'm going to try and move in here so you can see it. If you look at these areas here, if I grab this one, then it will just allow me to move things around the scene this way. So take a look at the X and Y coordinates, but the Y coordinate stays at 1, right? So can't move it up and down with the Y, it just moves it across the XZ plane, which is what I want. So kind of move it over here to the corner. And then I want to rotate it across the Y axis, something like 45 degrees. So something like that. Move it over again, right? So look at the preview here in the scene. And now I'm going to move it up on the Y axis. So kind of move it up here like this. And then I want to rotate across the X axis, something like 45 degrees. So if it's the wrong number, or if it's too steep, we can always change it. Let's go into something less steep, something like 10 degrees. And we can move it down so we can see the corner. I think maybe I liked it where it was, and maybe more than 10 degrees, maybe like 15 degrees or 20. Play with that number. There we go. It's kind of cool. So why am I doing it this way? Well, because in the simulator, then this is what I'm going to see in the simulator. And I want to be able to see an object that's inside of there. But again, a bit of an angle as opposed to straight on. A lot of times straight on is not the greatest look. Okay, And the other thing I want to do here is, along with the ground, which I'm going to tag as ground, I also want to bring in a version of crypto. So I'm going to go into prefabs, resources prefabs, grab a crypto, and bring him into the scene. There he is. So there's crypto in the scene. And in our simulator, it's going to look like this. For now, let's get away from the simulator and look at game. So this is kind of, remember, we want to just be able to see the object we're gonna play with in here. I'm going to move crypto so he is down over here, closer to us in the scene. So there he is. Again, notice I grabbed this little edge here, or this base, but not the other ones. And I want to rotate our object around the y-axis a little bit, just so we can see it a little bit easier. So I'm just going to rotate it kind of so it faces over here. And now you can see what that looks like in game. There's crypto. One thing to note is he's going to error out, right? If I run it now and he's going to just not move, and it's going to produce some errors. And the reason why is because crypto is looking for a player, right? So if I look at some of these objects, it says my health bar world space does not have a camera. So let's try and fix this problem. So again, I'll go into this. So here's my health bar world space controller. My computer's opening up stuff all over in different monitors today for some reason. So notice what it says is a player. I want to find the player cam, and then I want to do this. Well, what if there's no player camera? Like we have none right now. We don't have a player camera. We're just a regular camera. So I'm going to say something like if. We'll put this an if statement inside. We'll say only if player camera is there do we want to set this up. So I want to kind of put this in place here. And we'll move this away. So got that and put it here. So what this is saying is don't billboard unless there's a player camera. Okay, don't do this part. That's okay. If it doesn't get anything, it'll be null, but it won't affect me in here at all because I'm not using it. Okay, cool. So if that's the case, then let's see if they take some of those errors away. Again, we want to make it so that we can run it in the test scene without errors. Okay, so we're going to get some more errors. Now it looks like there's less errors. There's one error left. So what is this error? Well, it says, just like before, it says, well, we're trying to get a player cam, right? And what it says is a null reference exception. It says object not set to an instance of an object, health bar world space controller, as an example, is trying to get a reference to the player camera and to do something with it. So this is, again, it took care of this part because it's trying to update every single time, but it's still trying to find the transform of the camera. So this is kind of doing two things at once. That's what the player camera is, a transform of the player camera object itself. We can break this down into two parts. So let's rename this thing, which is the player camera transform. So let's rename it. So refactor, rename. By the way, it's not going to mess us up anywhere else because we're making it work everywhere. Player camera transform. There we go. Player camera transform is this. And then what we can do is we can say something that looks like this. Player camera is actually this part. So we're going to break down two lines, this part here. And we're going to say the player camera itself is this. We'll make this so that is a new. We'll make that private. We don't have to make that. Oh no, we can make it public for now because we want to troubleshoot. So we'll say public camera. Actually, that's a public player camera. And remember, if there is finding a game object that says that is of type player camera. So it's a type camera. And we'll call this player camera. Okay, with a lowercase p. So it says that when we do that, it doesn't like that because we don't know that it's a camera. We just care about the transform anyway. This, what it looks like, is just a game object. So it says, hey, game object, player camera, which is this. player camera is equal to this. All we care about is the player camera transform, this part, and that breaks it down into two pieces. Player camera itself, do I find a player camera? Yes or no? But then I don't need to do this. So I'm going to do the same thing I did up down there. I'm going to say if player camera, and then what we'll say is then that we'll do this. So we won't do this and try and find the transform of something that doesn't exist. Okay, so that kind of takes care of both those errors, and that should alleviate my problem. Let's see. So go back, and we'll run it. And now we shouldn't get any errors. You just should sit there and idle right now. Right, awesome. That's great. And one thing we also don't want to do is in the scene, we don't want to see the enemy marker, but we do see the enemy marker here. Why? Because the camera sees it. So main camera, notice it says that the main camera is, it's a test camera, so let's move this to like 100. We don't care about seeing it too far away. Make it a little bit more performant for us. It's using skybox, and culling mask is everything, but we don't care about markers, so we don't see that. Awesome. All right, so that is our little demo. It looks like it's running, and it's pretty dark. Let's also make it so we can see the face of this character a little better. What you can do is, just like we did for our main lighting, we can create another lighting for our test scene. So under lighting, you can see that there's no lighting set up for the test scene. Let's click on new lighting settings, and we'll call this the test scene lighting. And that is the lighting settings for our test scene. We'll make it so that it auto generates light maps, and now it'll be nice and bright for us, right? So we can see what the object will look like, right? This is what the object will look like after it's been lit. We'll put the animator over there for now. We'll move back and forth. So that's what it looks like when it's lit. But one thing I also like is if my light, look at the shadow, that's pretty mad, like really pretty bad. We have to improve that shadow. That's why we have a test scene as well, to see if we can improve stuff without anything else in the scene, just one thing at a time. All right, so we want to bring the lighting a little bit differently. So notice that the light right now, if I go to the inspector, is at 50 degrees. We can play around with this light. So we can make it so that it sees more of the character's face, or make it darker. We can play around with this all together as well. And we also can change the Y from what it was to 0. Again, it's only going to affect us in this scene, and that's a beautiful thing. This way I can zoom in, take a look at his textures and all that kind of stuff without having to work hard, right? Okay, cool. And so what does this look like in game? It looks like this. You know, I think I might want him to be even closer than this. So let's go back into the scene and do a little bit more translation for the crypto. Again, this is all in prep for what we're going to do in a second. So just want to do this and pull them across here and pull them right into the corner here, which means we're going to see this guy right in here. That's pretty good. We can see his shadow more, a little bit, maybe a little bit closer, right to the scene, to the camera. There we go. So then when I play the game, you can see that this scene alone, maybe a little bit back. And that's something that we need to do. Tiny bit back, just so I can see his feet as well. Notice also that his feet are, when I play, are sunken into the scene a little bit, but not here. This is pretty good. So that's what the actual game will look like. But take a look at this terrible shadow here. We need to fix this. If this is what it's looking like in the test scene, then that's how bad it's going to be on the device. We don't want it like this on the device. So one of our challenges is going to be, hey, can we make our little crypto guy that we downloaded, can we make this a little better over here? Great. We're ready now to translate across to URP. So what is URP? Well, URP is the Universal Rendering Pipeline, and what it allows us to do is change the way we light the scene in Unity. It gives us a bit more control. It's the newer pipeline that Unity has created. There's two new pipelines. One is the Universal Rendering Pipeline, and there's also something called the High Definition Rendering Pipeline, which we can't use for mobile devices, but this is great for mobile. It improves the quality, lighting, and everything else, and also allows us to use post-processing effects which if we have time for, we'll do that later. But we want to use shaders, and we can't do shaders or custom shaders the way I want to do them anyway without transferring to the universal renderer pipeline. So there's some steps that I've put here that you can follow along if you're not watching the video, or if you missed some step, you can look at these steps here. But I'm going to go through these steps with you right now. Okay, let's take a look. So number one, what we want to do is we want to upgrade our package to the universal rendering pipeline. So we're going to go to Window, and we're going to go to Package Manager. And under Package Manager, here's Package Manager. I want to select my Unity registry. And under the Unity registry, I want to scroll down until I get to something that says URP, or Universal Render Pipeline. This one, Universal RP. I want to install this. So I'm going to click onto it once, and down on the bottom, I'm going to click Install. And it's going to do its little dance, right? And there's several steps to make this work properly. Once we've installed URP, then what's going to happen is it's going to add additional components into our application that we can use to create shaders and so on. Now, just because we've downloaded URP doesn't mean we've enabled URP, right? So we could also choose the Universal Render Pipeline template when we first start a new Unity project. That is a whole different thing. It also includes example content and so on, which I don't want right now. So this is perfect. And the reason why I didn't do it earlier is for that exact reason. I didn't want to have additional content inside of our scene. We already have a lot of content, and so do you. So I didn't want to have that stuff, so I didn't include it. So now what we're doing is we're stripping it down to the bare minimum, which is this. Okay, and it's doing its little dance, and it's basically what it's doing is it's taking some of the information we already have and re-importing it back into the scene. It's required for us to get the URP ready to go. All right, so it did its little dance. It did everything, and notice it installed URP, and it also installed Shader Graph. So Shader Graph is where we want to play right now. I want to play in there, and I also want to do things with URP. It also installed the post-processing stack, so we don't have to install it manually ourselves. So between those two things, we've got a lot going on. Okay, those two things. Awesome. Let's close this down. Now that we've moved to URP, we need some additional assets. We need a universal rendering pipelining asset. So what we need is in assets, I'm going to make a new folder. Great, new folder. Let's call that URP assets. That's going to go at the bottom here, URP assets. And inside there, what I want to do is I want to create two new assets for URP. So I'm going to go into assets, create. And if you notice, if you go down to where it says rendering, there is this universal render pipeline. And what I want is this first option, which is pipeline asset forward renderer. That's the one I want first, this one. And when I click away from it, it creates two, this asset here and this asset here. So those two assets. Okay, so that's step one. Step one, we make a new universal rendering pipeline asset. And I did that again by going to right click. You can go through the asset window, or you can go to create. And if you go to rendering, you can create that universal rendering pipeline asset right here by right clicking. So create, rendering, URP, pipeline asset forward renderer. Once I've done these, this is step one. Okay. Notice that our shader is okay right now, but as soon as I convert from our old pipeline, which is the standard graphics pipeline that Unity has, to the universal render pipeline, this thing will turn into like these pink colors. Okay, let's see what I'm talking about here. So now that I've got this, let's open up our edit window and go to our project settings. Our project settings are going to bring up this little window here. And on the left, you're going to go to graphics. Notice it says scriptable render pipeline settings. There's none selected. I want to click little target now and select that new asset we just made, universal render pipeline asset. Once I do, everything becomes pink. This is a good sign. What pink means is that now we're not even looking at the old graphics assets or the materials we had before. All those old materials kind of point to old shaders. Okay, before we move on with the next piece, I'm going to warn you that if you have a lot of assets downloaded from the Unity Asset Store that has their own assets, their own materials, custom shaders, that some of this may fail for you. All right, I'm just going to warn you ahead. So please, before you do this, make a copy of your project to play with. Don't play, or another branch as an example, don't play with the original assets, because what if you can't convert it afterwards? Right now, we're going to convert it because I don't have a lot of materials. But for yours, you might be using someone else's downloaded packages from the asset store or someplace else that has custom shaders. And some of that custom shader stuff is not translatable so easily. All right, so there we go. We have this, and I want to upgrade my shaders to the URP. So I'm going to go into Edit, and down where it says Render Pipeline, it's going to say something like Generate Shader Includes. I want to click on this button. That's the first thing. Generate Shader Includes. Give it a second. You're not going to see an effect. There's not going to be something that's going to pop up for a second, okay? Just give it a moment for it to do its thing. The next part is I'm going to go back in there, Edit, and I'm going to go back to Render Pipeline, and then choose Universal Render Pipeline, where it says Upgrade Project Materials to Universal RP Materials. Now, some of them will be updatable. Some of them will not. If I click onto this, it's going to say, are you sure you want to proceed? If I click Proceed, it's going to translate some, but not all. Take a look how the background did not translate, but our little guy, he translated. Why? Because our ground does not use a custom material. It uses the default material that's built into the old rendering pipeline for Unity. So if I look at materials here, there is no ground material. And if I look at ground, what it looks at is something called default material. Let's make a ground material for ourselves. So we'll right click here, I'll make a new material. When we make a new material, by default, it chooses Universal Render Pipeline Lit. So those are the options, Universal Render Pipeline, and then you can choose in there whether it's lit, unlit, complex, or you can use Autodesk Interactive, which is probably what's happened here when it translated over. I'm just going to choose Universal Pipeline Lit for the ground, and we're going to rename this, of course, to Ground Material. Okay, just to show you what that looks like. And if I drag and drop it onto the ground over here, automatically it should translate to this. That's using the new material. Let's change the color, because I don't like this base color. I think it's a little bit too bright for the background, and I need a little bit more contrast in this. Let's make it kind of a beigey color. So I'm going to bring this color value down a little bit. That's more of a gray. And if I go into the oranges, this kind of stuff, red-orange color, then we can make it so it's kind of this other color here. Again, a bit of, so it's not as stark on the eyes as it was before. And that's our ground material. Awesome. So that is the ground material. Notice what has also happened is I have a workflow mode, which is metallic. I can also choose specular. It's just going to change the way the shadows bounce off the ground. I'm going to keep it to metallic for now. Next is the render face. Is it front, is it back, or is it both? If I choose both, that means both the front and the back face is going to render. I only care about front. Okay, and that's the default material. Everything else is as is. And it looks pretty good. And if I run it, we should see that everything works as you would expect. It's got translated, and that's the first step. So URP is now functional. Wonderful. I want to bring in my, I kind of made a couple of additional things here. If you look at our, if we go back and let's take a look at our resources, prefabs, we have a bunch of stuff, and there is a pillar that we have here that looks like this. I want to bring this pillar into the scene. So let's bring it in. So I want to kind of bring it into the scene here. And let's make sure that the values here are 0, 0. You can see that we have a pillar in here and the 0, 0. We have a wall. This is kind of something we made together in Blender, remember? It's been a while, right? But you can see that the Y value is 0. Let's bring this down to 0 here. And that's our pillar. Okay, so again, it's kind of behind the other character over here. I want to bring it, I want to slide it across so that we can see just this part here. And I want to make it so it comes behind the character when we see it in the scene. So it's going to look like this. Let's move it a little bit to the left just to make sure that it is It's good. Maybe a little bit more. Good. So why am I doing this? Because now you have a real contrast, and this thing here is our new shader. I want to make this new shader appear here on the pillar. Remember what the pillar has. The pillar has a stone wall material. If I look at the stone wall material, so if I go to my materials folder, I have stone wall. Here it is. Under stone wall, I have several different pieces. One is a normal map. This normal map has not been created as a normal map. So one thing we can do is, if you look at each of these pieces here, this should say, if I go back to default, it looks like this. But if I click on normal map as an example, if I go, first of all, let's flip it to normal again. So let's flip it to the default and press apply. And then let's flip it to normal map again. So flip it to normal map again. So instead of default, make it normal map. And then click apply. And that's not really what I'm looking for. That should turn kind of a pinkish color. So it's not exactly what I want, but what we're going to get the effect of on the wall is more of a normal map. Might have that original texture. Hold on a second here while I look it up. So I'm not happy with that texture. It's just a texture. So remember, I gave you guys this several weeks ago. But let's bring that up one more time. So again, I'm going to go to my downloads folder really quickly and grab that texture for the normal map. I think it's this one. Yes, that's the one. And notice that this is what a normal map should look like. Again, if you look up online, I'll put this up in a second. But I want to rename this. I want to get rid of this one. Let's get rid of that. And I want to change this to stone wall N. So stone wall N. This is not going to be a default texture. It's going to be a normal map. And I'm going to click on apply. So that should apply it as a normal map. Now, if I take this and apply it to my material, if I go back to my stone wall material, so stone wall, and I apply the normal map by dragging and dropping it in there, again, a lot of these things I've already given you, right? So here's my stone wall. Now that's better. That's better. Look at that. That's way better as a normal map than I had before. I have a metallic map here. If I had a metallic map, it would go here. And I have a roughness map that would go in here. You can choose the roughness that you want. I'm going to choose a roughness of 0.3. But that's the roughness map right there. And there's also an emissive map. So I want to pull in the emissive map. I can do that for the wall. I don't have that right now. And there's also an AO map, an ambient occlusion map, which I have in here as well. So that is my pillar. And what I want for the pillar is I want to use some of this stuff again with my own shader. Wonderful. All right, so that's my pillar. Okay, and what I want to do here is I want to recreate my object. So what I'm going to do is I'm going to take my pillar, and just to be safe, I'm going to go into Prefab, and I'm going to unpack completely. So my pillar is not a prefab anymore. It's my own version of the pillar. And I want to make a new pillar material. Let's do that. So I want to say right-click, new material. We're going to create a new pillar material. So pillar material. And I'm going to take that new pillar material and drag and drop it onto the pillar instead of the one we have right now with all these bricks. Okay, so I want to grab this pillar material and drag and drop it onto the pillar, which makes it look like this. Perfect. So that's the one I want to mess with, this pillar material. Right now, it looks like at a universal render pipeline lit shader. I want to make our own shader in a second, and we're going to do that very shortly. So I need a new folder, and I always like to have another folder for shaders and so on. We haven't really have any other shaders in here. Let's make a new folder for that. So right-click on Assets, make a new folder called Shaders. There we go. In my new folder for shaders, I want to make a brand new shader graph shader. So the way to get that is you want to right-click, create, and where it says new shader, I want to choose where it says under Universal Render Pipeline, it says lit shader graph. So again, so I want to go to shader, universal render pipeline, lit shader graph right here, and then click it. It's going to make a new shader. I'm going to call this the pillar shader. Okay. So pillar shader is of type universal render pipeline shader graph. Okay, that's what it is right now. I want to double click this asset to bring up my new shader graph environment. And then I'll go through shader graph with you. So double click on pillar shader, and it's going to bring up this. All right, so now we've got something new. This might seem somewhat familiar to you because we've done something like this with node-based programming in Blender. Remember, we did our own custom shaders in Blender way back, like week 2, right? So 10 weeks ago. So coming back to that, this is similar to that, but here we have 2 piece parts, right? One is the vertex shader, and this is, if you remember, we talked briefly about the graphics pipeline. It goes, vertices get broken down as an example, and they go into a program called the vertex shader. From the vertex shader, and again, I'm really truncating the pipeline here. There's many more steps here. Well, not many, but a few more steps. And it goes from the vertex shader through, there's a middle step here that's missing, that's not being viewed here, through the rasterizer, and outside on the other side, into the fragment shader. Again, there's pieces missing in the pipeline here. But the ones we care about are the vertex shader and the fragment shader. So those are the 2 pieces that create our the look and feel of our material. Remember that what the material is a preview of what the surface, that's what these are, surface shaders. The surface of our material is going to look like based on the light approximation that we're using, the calculations that we're using to simulate what light will look like in the real world. Yeah, that's what it is. Wonderful. So this is very nice, and we have some inputs here. Notice that we have a precision, we have the active targets, which is universal, we have a material that is lit, we also have a workflow that is metallic, right, and a surface that is opaque. We're going to leave all of this the same, okay, for now. But what I want to do is play with some of these values in here. So here's what I want to do. I want to make that pillar, it's almost like a pillar that I've selected, an object that I want to destroy, a destructible object. And I want to make it so that it glows, right? I want to make my own glowy effect. I kind of did my own selected effect earlier, but you know, that selected effect that we kind of used perhaps earlier on in this semester, it's probably not going to work the same way, all right? So that's something that we're going to replace it with something of our own. We're going to make something that glows. That's the effect that we have. So this is the preview. And by the way, the preview doesn't look like our pillar. Let's bring in another preview. So if I right click here, I can choose other things. I can choose a capsule, I can choose a cylinder, or I can choose a custom mesh. And I want to bring in the pillar material for our custom mesh. So that's what I can do. And we can rotate this thing, right? So we can make it look like our pillar in the scene right now. And a lot of times I want to get it from an angle so I can see what the angle looks like, where there's a lit side, and I can see a dark side, and so on. So you kind of bring it in here. You can rotate it if you're careful around inside this preview window, right? Like so. Again, if you're seeing something that's pink in here, you haven't set up the universal render pipeline properly, please refer back to the earlier part of my video where we did it. Great. Just going to bring it so we can see the corner again, like that. Something that looks like this. This is a preview. All right, so what I want to do is I want to make an outline effect first. And what this is kind of a standard way of learning how to use, I would say, the shader graph. Again, what I can do is I can zoom in and out with my middle mouse wheel. If I take my middle mouse wheel and press onto it and drag, I can pan the scene around. So I can move this area here. You can see that I have the blackboard that I can kind of pull up, right? Here's my graph inspector, which is this part, and this is my main preview, which is down here. So all these things are clickable. Color mode, I can select what I want to have. If I want to, right now I'm using none, right, for color mode, but this is kind of my little area, my little area that I'm playing in, my playground, if you will. So what I want to do is inside of the base color. So if you look in there, there's a base color input. And I'm just going to hide these things under here. So all we care about is the inputs right now. Okay, so it says fragment shader. This is a fragment shader down here. And we have several inputs. One of them is base color. There's base color. And notice there's a little number beside base color, 3. This base color 3 means it needs a vector 3 object, X, Y, and Z, or R, G, and B, red, green, and blue, right? That comes into the base color. So that's what we need as an input there. And we also have an emission, which also takes in a vector 3 object. But the other ones, for example, metallic, smoothness, and ambient occlusion, they only take a vector 1, which we can see as a float. So X, there's only X's here, not X, Y, and Z. What we want to do is we want to replace the emission kind of channel. We want to kind of input into the emission channel something that is reasonable. So a couple ways to get nodes, like we've done in Blender before, right? And for now, I'm just going to hide this piece here because we don't need to see the graph inspector. We just want to see. And for now, I'm just going to pull this main preview so it kind of hugs the bottom. So all we care about is seeing this. We don't care about the fragment shader, and all we need is this input right here. So I want an input into the emission, and I want a node. A couple ways to get nodes. You can right-click, and you can create a node, or, which is easier, just spacebar. Spacebar brings up the node selector. So that's the 2 ways to add a node into the workflow. So let's add a node here, and the first node I want to add is something called a Fresnel vector. So it's a vector effect, the Fresnel effect. If I add it in, double-click, I get this new node, and it gives us a preview of what it looks like. We have some kind of haziness outside. There's the area that's going to glow, and some kind of black area in the middle. And if I take the output of this one, notice that these ones are all blue, and this one is not. This one is yellow. So what's going to happen is if I take the output of this one and drag it into this one, I'm only going to care about the X value, the power of how much this is going to be. The Y and the Z, I don't care about. And that's what's going to happen. It's going to kind of cast this down into a single value. All right, so all 3 values, X, Y, and Z, are going to have the same value on X. And notice what this does. It produces a bit of a glowy area. Okay, that's what it does. And here is our, you can see our effect. And if I want to save the effect to the shader, first of all, let's take a look at the shader here on the right. We're going to go into shaders, and we're going to click on the pillar shader. There's the pillar shader here. And you can see this is the pillar shader. But in the materials that we want to see it on, the material itself, we want to see it on the pillar material. Right now, the pillar material is not pointing to this shader. It's pointing to the Universal Render Pipeline lit shader, which is this one. This one is checked. I don't want to use this one anymore. I want to use our own. And the way to do that is to go down to here, go to Shader Graphs, and choose our pillar shader. That's what we want to use. Once I've done that, then all of a sudden now you see a real-time view of what my pillar shader is going to look like. And if I save the scene, so I've saved the asset, right? I've saved the scene. You can see now when I save the asset, it actually glows. This is what our shader is going to look like. So if I look at the scene now, then so too does that scene. The scene actually has the same effect. Whatever we see in the shader, it looks kind of like this glowy effect, and the whole thing glows white. Nice. Let's go back to the pillar shader. So what I want, just to give some contrast, is let's make this a color value. And so what I'm going to do is I'm going to drag from here in there like this, drag a line in there, and then I'm just going to choose color. I'm going to choose, for now, I'm just going to choose the base color. So input, base color, color at 4. It's going to give me this color value. Okay. And in my mode, I'm going to choose HDR for the color value that I'm going to get. Okay. I'm going to select a blue color. Let's select a blue color. So blue, blue, blue. And let's make it so it's blue and everything else is 0. And let's make it so that my alpha transparency is 255. So it's completely opaque. And that's my color. So that is the color that's going to be applied to the base. But notice this doesn't show up. Why? We need to save the assets. Once I save the asset, then all of a sudden, boom, we have this little outline, and then the inner color is blue, and the outer color is this color. So for now, this is okay. And if I go back to the scene, you can see that sure enough, we have kind of a glowy effect on the edges, and in the middle we have blue. Okay, so far so good. But what I really want is for this thing to be blue. And let's turn the power up so we can make the power of this thing go to something like 3. And when we do that, you can see that there's more blue on the inside and more of a rim kind of color on the outside. And that's kind of the effect I want. So let's save that. And I can see that the effect immediately goes a bit of glow on the outside and black on the inside, which is this color here. Because I'm taking the color, modifying the base color, and the emissive effect, which is white right now, is the thing that's hitting the emissive channel. So again, I've saved that, and I go back to the scene, and you can see that sure enough, we have a bit of a glow on the edges, but mostly blue on the inside. I wouldn't mind if I could change the color on the outside, and instead of making it a white glow, I want to make it a different glow. For example, something like a yellow color, right, which is a good contrast with blue. So again, I'm going to go back to Pillar Shader, and I'm going to go and I want to make this yellow, but there is no way to do that unless I do some other kind of effect. And what I'm going to do is I'm going to drag this out. These ones I'm going to keep here for now because I don't care about this color right now. But what I want is another color node. I'm just going to zoom in here so you can see it. I want another color node that goes kind of with this one, and then it goes into the emissive node. So I want to take 2 nodes, do something to them, and put them in here to produce another color. Well, let's first get rid of this line. So click on the line and then press delete, which kind of removes that line. Remember, we haven't done anything until we press save asset. Right now, it's still the older one. Okay. What I want is a color node that looks like this. So I want a color node. So again, spacebar, color, and I want to go with basic color. Scroll down where it says basic color. Here's our basic color. And in here, I want to change the basic color to yellow. Yellow, 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 right? And what I want is for my alpha transparency to be 255. And I want to change the default mode from the default color mode to HDR. I want to take these 2 things and combine them. Wait, what did I say? Combine them in order for me to get another effect. So the way to do that would be for me to make a multiplier node. That's how you can combine things. Okay, so again, I'm going to press space and type in the word multiply, bring in the multiplier node, and now you can see that I have 2 inputs. I have a blue input that goes here, and I have this output here that goes into here. Let's try that. So I'm going to drag and drop this one in here. This is the original effect, like this. Then I'll take this node and drag and drop it into here, which gives me yellow. Okay, pretty simple. And now, if I want to, I can take this yellow node and take it out and put it into the emissive channel here. And if I save asset, you're going to see that this now is yellow. And I'm going to go back into the scene, and you can see now that, well, you don't quite see the yellow too great. Right? You see yellow here, but it's not really apparent there. And in fact, if I look around the scene, it's kind of more white than yellow. And you're going to say, why? Well, it's all down to how bright the yellow color is, and that if it's opaque or transparent. Right now, I've made it fully opaque. And I'd have to go back into the pillar shader every single time and modify it to see the effect on the outside. That is kind of a pain in the ass. What I want to do instead is I want to be able to show properties here. This is like my shader. I make my own custom shader. I want the properties to show up here, and the way to do that is to take the color output here and convert this into a property. So I'm going to right click, and I'm going to go down to convert to and make it into a property. When I do that, it becomes a color here. I'm going to call this emissive color. So rename emissive color. I'll make it the Canadian color instead of the American color, right? That's the one I want. And if I save asset, now you can see that I have an output or an input that goes over here. And what I can do is I can drive up the values of this color, maybe a few, to make it really glowy. And let's make it so that it is semi-transparent, something like 128. So you can see I can modify it up here instead of doing it in here. That's good control. I like that. And so if I save my asset now, this is all good. What I can see is if I go back to my scene, then I can see more of a yellow flare to it than before. Again, difficult to see, but if you look at it from the angles, you can see that, yes, indeed, I have this kind of an area that is somewhat on the edges transparent, or sorry, yellowish. Okay. The other thing that's happening is we have a lot of blue, right? And the reason why the blue is coming up so much is because we have a fully, our base color right now is fully opaque. We have no control over it here because right now the only thing we've exposed is the emissive color. Let's expose that too. So I'm going to go up to here, and where our color value is here, our color input, let's right click and go to convert to and make it a property. I'll make this property come up higher than the other one. We can reorder properties like this and right click and rename, and we'll call this base color tint. Base color tint. Okay, again, you can call that whatever you like. You might call this albedo color or whatever. And if I save my asset again, then I have my base color tint up here, which is very blue. I can go down here and change these values to 128. And again, I can change the values. Any color I want now is available. And if I go back to the game, you can see again, no difference there, but you see that there's a bit of a glow on the edges. Awesome. It's great. All right, that's fantastic. I have my pillar. I have one little color, and that's all I have. But you know what I really want? I really want the ability for me to make this thing glow. So it's going to kind of pulse. It's going to glow on and come off, glow on and come off, almost like in a rhythmic pattern to show that I'm selecting it. So how do I do this if I want to put this material on? Well, I have to have a time dependent function in order for me to do that. So when I just said time, my thoughts are, man, I need a time function for this. So again, I'm going to zoom in. And down in here, I'm going to make another function. So I'm going to kind of go here, press space, and type time. And if I go time, you're going to see that there's the time function has a bunch of outputs. Time by itself, sine time, cosine time, and delta time. So you can make things happen every frame if you want. That's what this is. Or you can make things happen according to a sine wave, where it goes from a -1 to 1 value. I want it to be this one. All right. So what we're going to do is we're going to take this one and take this part and multiply it together to get a on and off value. So I need a multiplier. So let's do that. So we're going to grab another multiply node. And this multiply node is going to get, instead of it going directly into the emissive value, it's going to go from here into this. So by default, we get this black value. And then what I want is I want to go from time, sine time, into this. So it's going to kind of glow according to my sine time on and off. Notice it's going to glow on and off. But the problem with this is it goes from a -1 to 1. And how can I have a negative color? I wanted to go from 0, where 0 is completely off, to 1, which is completely on. So I need to remap this from 0 to 1. So I need another node in between called remap. So here's my remap node. Remap, all it does is it takes a value. So here's my influx. Here's my input. Right, there's my input. And then I have a minimum, so -1 to 1. That's the normal range. And then I have my remap value from 0 to 1. So I'm going to go from 0 to 1. And now I can take these values and output it to here. And you can see now that it's going to go from 0, where it's completely off, to 1, where it's completely on. Okay, and that's what's going to show up here. That's completely on, and then it's going to be completely off. And if I don't want it to be completely off, maybe I want to make this at 0.2, something like that, where it's not completely off every single time, but some glowiness around to it. And then from there, I can take that out and put it into the emissive value. And let's save that and see what it looks like. So if I go back to my scene, you can't really see it because, remember, it needs to be running for you to see that glowy effect. But let's run it and see what happens. So here's I'm running the game now. And we're going to see that it should kind of turn on and it should turn off. So that's off. And then it's going to turn on. and go off. And it's kind of a very subtle looking effect, right? So you can see that it turns on and then goes off. It glows at the edges. There it is, and then turns off. That's pretty cool. So kind of an interesting little effect or whatever. And we did that simply with our pillar shader. That's what we're doing here, okay? Again, I can really turn up the strength of the value by going into my color, my emissive color value, which is here now, right? And really turning this up. Right now, my intensity is 3. I can make this so it's way more intense. Let's make it so it's like 5, right? So you can see that's way more intense now than what it was before. And once I've got that and I save my scene and I try it out again, it'll give me a different effect. Again, everything is out exposed here on the shader, and you can see now that it's going to go away, and you're going to see a much stronger effect on the sides. Again, this is relative to my camera. Okay, so kind of a glowy effect. Subtle, but pretty cool. All right, so now that I have that, and it kind of glows a little bit and kind of goes away. Again, this is, as you notice, there's several steps here. I want to make it so that I don't always have that. I can turn it off and on. I want to be able to apply this shader anytime I want. Maybe I want another kind of glowy color in the middle or something else. And what if right now the middle color is my, what it's going to look like. It's going to be an effect of my, kind of tinted with my base color as an example. Maybe what I want is the middle color also to glow a certain amount as well. So remember, I can combine these to create whatever I want on the inside, right? So again, I could add another color in here. Remember, as the output goes out, this turns it on or off. That's all this does, right? And I can multiply this by something else before this goes into this multiply step. So again, if I want to try that, I can disconnect these and I can add another color value. So let's try that out. So I want to go color, and let's go base color. And let's suppose I have this base color here. I'm just going to space this out a little bit more. So I'm going to kind of select both these two things like this, move them across, just like this, so they're a little bit off screen. Here's my base color here on the left, and then let's add another multiply node, see what happens. So we can play around a little bit. And by the way, we can also turn some of these a little bit smaller so they can fit. We know what we want is the last part. The stuff that's working, we can kind of minify a little bit so we know what it looks like over here. Like the Fresnel effect, the multiply, and the emissive color, those aren't changing, but this multiply is. And what I want to do is I want to take a color value. Let's make this color something else like green, right? And again, we'll make it so that the color is an HDR type of color. And this goes into this part, and this goes into this part. And you can see that it glows green and then goes all the way down. So you can see that that kind of combines, right? What I can do is I can take this part and go in there, and it'll shade the whole thing green now, right? As opposed to what it was before, right? So you can change this color here, this other color, which is the tint of this color right here. So here's my emissive out, and then I've done it again with this one, which is the one that combines with this to create the inner effect, right? So if I go to green, and I can turn this, let's say, all the way up to 255, and I can make this turn this up to 5 as well, really, really bright. So double, kind of a double intensity. As an example, you see like there's blue, and there's it goes from blue to green, fully green, and there's blue in there, just combining to form the final color. And if I click Save Asset, you're going to see that it's a different kind of effect. Let's see what that looks like when I combine yellow and green together. And if I go back to the game, and if I run it now, you're going to see a different kind of effect. It's kind of a pulse. Right? You may not want that. And I may want to turn that off. And I also want to control the color. So what does that mean? I'm going to make it so that I have some of these values out here. So one of the things I want out here is this one. And this is kind of my pulse color. I could turn this completely off. as an example. So let's go right click, convert to property. So that's the one thing I want. And I'll call this the emissive pulse color. So rename emissive pulse color. And this is the emissive rim color. So let's rename that one, emissive rim color, right? So the rim color and the pulse color, and I'm going to save the asset. So now we'll have both colors out here represented. Again, you could turn this completely off. So let's say, for example, I want it to be transparent. I can just kind of go out here like this, make it white, and then turn this to 0. And then, well, there's nothing, right? I don't have any kind of color value at all. And I can even turn this completely off, right? So, you know, where I don't want to make this, you know, kind of on at all. I can also reduce the intensity here to 0. So I don't want this to change. And now you will see the blue, the yellow and the blue again. So it's not going to really be effective, but it's another step that's in here. So this is the multiply. I'm getting the remap, and I'm getting this piece here. We can kind of reduce these now. We know they work, right? So this is these values here and the remap value. Okay, so that's the final effect. And if I was to go back and play the game again, play the scene, you can see now that we have a much more subtle effect, right? Where this is kind of an emissive color pulse is off. We're not really using that. So the emissive rim color is on, and we're using that, right? It's kind of coming up subtly and going away. And there it is, all right? We can make it more intense, you know, if we want to. But what about if I want to turn that whole effect off? Like, for example, let's say I don't want the, I don't want this thing to turn on at all. I want to make it so that, what if I don't want to have this pulse at all? I just want to have a solid rim color on all the time. How do I do that? And so I can turn it off or on. Off or on, that sounds like it is a some kind of Boolean. So let's add that in. So go here and go to Boolean. And Boolean basically is an on or off value, right? And what on or off does is it takes some kind of value plus the Boolean and does something with it. We need to have something called a branch. Here's our branch where the predicate actually is the Boolean. It's kind of up here like this. The predicate is the Boolean. So that's on or off. And we'll turn it on for now by default, right? And the multiply, well, that's the other value down here. So when it's true, it's going to be on. This part's going to be on. But when it's false, right? When it's false, I want it to be fully on down here. So where it basically says I have an X, Y, Z, and W value, I want this thing to be fully on. Right? So that means that these values here would be completely on. All right, so that is the branching value. Then I can take this and go here. So that will be the same thing. But I can turn it off and on. If I turn this off, then what you're going to see is it's just going to be whatever this value is going to be when it's the off value. And again, what I can do is I can have another value in here. So let's kind of pull this out. So we're going to have a float that's in here. And that float can be fully on when I have the value. So the float basically is the off and on value. If it's what happens when it's off, this thing is completely on all the time. It's persistent, right? Or I can turn the pulse on and it'll come on, right? I don't want to expose this piece. This is just a kind of an on or off value. I could have also made this a Boolean, right? If I wanted to, right? But this one I want to make into a property. So I'm going to do that. I'm going to make this into a property. And I'm going to call this emissive toggle, or not emissive, the toggle pulse is what we're going to call this, right? Which makes sense. So rename to toggle pulse, emissive pulse, right? And I'm going to save that. And now you're going to see a little button that goes on here, toggle emissive pulse, where I can turn it off or on. If I don't want it on, I can just turn it off, and it'll just be on the whole time. And what this will look like if I run it, it'll be fully on all the time. So that little area around it, right? Or if I turn it on again, it'll start to pulse again. It'll kind of come on and then go off again. Nice. So that gives me the ability to do those kind of things. All right, so really what we've worked on in this pillar shader here is we've worked on the whole idea of the pulse. We can do other things. We can add the speed of the pulse. I can multiply kind of another value for time that remaps. Instead of 0, 1 to 1, I can kind of do almost like a strength, right? The other thing we didn't output as well is the strength of the Fresnel effect, right? For example, right now we have a set at 3. Let's make it so that I will say that the kind of a rim effect strength or rim strength or rim power, we'll call it rim power, right, is what this thing will be called. Now notice it says 0 and 2, right? But we only want a, instead of a 2-dimensional vector, we want a float. Sorry about that. And this will be, we can kind of rename this. We'll say convert to property, and we'll rename this to emissive rim strength. And we'll move this up. So the amount of color and then the strength. Okay, and we'll save it. And we can see that we have the emissive rim strength. If I leave it at 0, it's fully lit. So if I go back to my game and I run it, it's going to make it completely yellow. If I increase the value, let's say I make it 5, it's going to make it something that looks like that. Or I can move it down to something like 3 or 2, or 1, which gives me more and more power. The lower the value, the more it's going to glow. All right. So that's something that we can work with. All right, which is pretty cool. So completely on and completely off. It'll pulse this way. It's something like this. And we can turn it off. And if we turn it off, it just stays on. That's the way it works, right, for that value. So let's put it back to something like a 3. I think that's more reasonable. It can pulse, but it's not going to be like as insane. And if we want another value in there, let's say 3 is not enough, but we want it closer to 2, or as an example, or 1.5, where we don't want it quite as subtle, more striking, we can have those kind of controls. Again, anything you expose here is good because what it does is it allows us more control. All right. Let's go back to Pillar Shader, and we've done all this. So again, you can see that we've added, kind of different things here. The other thing that we want to do is, one last thing is, you have a 2-dimensional vector here, right, where you have x at 0.2. So this is how much it turns off. Does it go to 0? Does it only go to 0.5? That's another thing you want to expose here, the pulse, how much it goes to 0. The minimum value is what we want here. Again, what I want to do here is go here and add in a vector 2. So a vector 2 value. And then we don't want to change the y value. We don't give the option for the y value to change. It's just the x value that we want the minimum value. So then from here, we want another one, which is the float. And that float will be something we expose, and we'll say that this is the minimum emissive amount, minimum emissive value, or minimum luminance, or whatever you want to call it, right? So let's go to convert to property, right? And we'll rename this to minimum emissive value. And the minimum emissive value will be like something like when you're pulsing, it only works here. So I'm going to put that just above that one and save the asset. That's going to give us a value. So 0 is the minimum, but we can go to something like 0.2 or even 0.5. So 0.5 means it'll only go to half as dim and then go all the way up. So again, lots of control here as we're making our shader. And what I can do is I can go to the scene, and you can see that when I run the game, that you're going to go only to half as dim, and then it's going to go down. So it's not going to go fully dim. It's always going to be lit, but it's going to go all the way up to the top and then all the way back. And if I don't like this, and if I want the emissive strength to run a little bit stronger than this, then I can go to something like 1.5, which is going to give me that strong upward and lower middle. Kind of like middle is going to be something like this, and then it's going to go right to the top, like really, really bright and glowing, right? Again, it really depends on what you want. And notice when we emit light, it's actually emissive value that changes the light on objects around it. Okay, cool. So that is something that's really cool. By the way, if you click on emission here, right, and we click on, so what this does is it actually starts to create, it's almost like we can make this act like a light. Right now it's not, but for now, let's just turn it off. And what this does is we've done this piece here, and I want to save those things. So in my pillar shader now, with this little network of the shader network I've created, this is really the Fresnel effect, or the rim effect, if you will, right? So I want to bring these closer. And then I want to kind of select all these and select this and kind of make sure this is smaller. And this is kind of my main effect. I can turn these off and on later. And what I can do is I can select everything, right? There's everything. And I can right click and I can group my selection, and I can call this something like, you know, rim effect. There's my rim effect. And now this whole thing I can move together, and so it's all one thing. It's pretty good, and it's done. But you know what? I would really love for me to have the ability for me to have my textures back. I don't have those textures right now. I only have like this blue. And blue is cool and all, but I wouldn't mind if I had my texture as well as blue. So I could tint it if I want or not. But I want to bring in my texture, which is going to be my my wall, right? Which is this texture right here, stone wall, which is my diffuse texture. Okay. So let's break the line here. And what I want to do is I want to get a texture. So if you type in texture, you can go to a texture RGBA. That's what I want. Texture RGBA gives me input in here. And what I want to do is combine these two things together to give me an output. So obviously I would have to multiply them. Let's do that. So we'll say, let's make a new multiplier node. And it'll be in between these two things. So this one will go here, and I'll multiply with this one here, this output over here. And what we'll do is we'll take these two things, and it'll go into my base color over here. Okay. But what I want is for these two things, and notice it says tangent space or object space. The default is default or normal. I want to make it default, and I want to hide this stuff so I don't see any of this stuff here, right? And just making it smaller. I want to have an input for the texture. So I'm going to drag from here, from this sample texture 2D, I'm going to drag it out again. And from an input, I want a texture input. And this texture input is something that I want to replace over here. So I want to make it so that this is the diffuse texture. So right click and convert to property. And I'll call this the diffuse texture. So rename to diffuse texture. You also can call it albedo if you want to. And I think it might go better if it's next to the base color up here. And if I press save asset, then you can see that I have a little space there for my diffuse texture now. Now I take my diffuse texture and drag it in. And now you can see that I want to have both of those combined to create what this is here. But remember that my current texture is 128, and I don't want to use it at all. I want to make it so that it is completely opaque, so 0. And so I don't want to use my tint, but I can have it if I want. So here's what it looks like now. So there's my diffuse. I can see the brick color in there by default, right? Again, you can also look at what it's going to look like here as a preview. And I want to save my asset. And I'm going to get my preview in here. Let's take a look and see what it looks like on my game. And you can see now that it has a bit of a, if I run it, it kind of glows and it's really glowy, and it goes down to about half as much, but you can see the brick there. It's almost like I've selected the whole brick wall that I'm going to kill. It's a little bit too much for me, so let's bring these values down to something that's reasonable. 0.1. As an example, 1.5 is pretty good from a rim strength perspective, but 0.1 is it'll turn off like to some degree, right? So it'll go on, and it'll go mostly off, and it'll pulse like that. So really saturated and desaturated at 1.5. You missed the strength. Okay, pretty cool. Again, if you think this is too much, you may want to try other values like a little bit subtler, like this, maybe 1.9. You know, if you don't like that, maybe 2.5. You got to play with these values a little bit, right? So that you get the result that you're satisfied with, right? So 2.5 seems to be a good value. Right now it kind of turns on, but I can still see the brick behind it, and it's not too bright. These values stay, by the way. All right, cool. So I've got my diffuse texture, my base color tint, and I've got all this. Well, let's add the rest. And okay, so this is this part of the node, and this is all to do with my diffuse color channel. So let's kind of, you know, select all this, and I'm going to right click, and I'm going to group selection. I'm going to call this diffuse color channel. That's what this is. And you can see I can pull that away, and I've labeled it, right? So we can always use it or not use it. You can copy it into other things as well. I want to do my normal map now. Let's do that next. So drag it over here. I want to make a new texture, just like we've done before. And we want to do an RGBA texture. There it is. But this time, instead of the type being default, we want it to be normal. So a normal map. Tangent space is correct. And then what we want is for it to be an input, which is a texture input. So texture. There it is. And I want to right click onto this and convert it to a property. And this property here, I will rename to normal map. With my normal map texture. Could I include a color to tint my normal map? Yes, I could, if I wanted to. I'm not going to do that. I could also change the strength of the normal map and all that stuff. The answer is going to be no right now, but I could. I could have another value that's in here that could change the strength. I can combine this with a value, like a floating point value, that increases or decreases the values that I get from all of these. Right? Multiply it with something. So multiply value could do that, or a clamp. Normal map texture, if I go here and I save asset, you're going to see that it appears down in here, and I can take my normal map here and drag it in, right? Pretty good. And you can see now that I got a pretty good idea of what this looks like. And let's take a look and see what it looks like in game. It looks a lot better, right? So if I run it now, you can see that we're starting to get the brick texture through. On the brick, you can see our character is still good. And we're good to go with the brick. Normal map is there. Awesome. I like it. So what do I mean by that when I say, what about if I want another value? Like right now, our normal map texture is whatever we want. Whatever it is what it is, right? But sometimes we want a little subtler effect. We don't want the whole value, the whole strength of the normal map to be in there. So what I can do is, what if, again, you had another value. So let's say we had a floating point value. Can that work? I had a floating point value, and then I combined this two thing in the multiplier, multiply, mult. Now what will this do? So I take the multiplier in there, and I take the strength of this in here, and we take this part out here and put it into the normal map in there. And then if I did that, and I click save, and if I put 0, because right now we can see that the this value is not being seen. Notice there's no normal map inside here. Let's put out let's change the value to something that's reasonable. Let's say 0.5. Let's see what 0.5 does for us when it comes to the normal map value, right? So if I take the normal map and I save my asset and I make it 0.5, you can see that it's somewhat there. But but I don't want to do it in here all the time. So that's kind of my normal map thing. What if I made it something bigger, like 3? Is that a thing that I can do? Would that drive up all the values of this thing? What would it do? So again, if I save my asset and change to 3, it doesn't really glow too much more. It has a limit, but it fully turns it on. So something like 0, and you can create a ramp, something from 0 to something else. For now, we're just going to leave it as a floating point value, but we're going to save it to our property, which we're going to call this the normal map strength. Rename normal map strength. Save, which is going to appear here. We can put it, let's say, at 0.5, or if you really want it to be at 0.1, or something else. It'll be a lot subtler than what it would be if it was something like fully on. So for example, from 0.1 to 1, you see it's going to be more striking. And sometimes something as low as 0.5 might be more reasonable for most brick textures. So again, if I go through here and I look at the map, you can see that that's not bad. But if I wanted to turn this right up, you can see that I can play with the values in here and in real time and see what that looks like. Okay. Again, I think 0.5 is good, but I can also turn it off. So let's say I have a normal map, but I want to turn it really low, right? Really, really low, 0.0 something. I can do that. And it'll either turn on or off, right? That's kind of what it does. So not exactly what I was looking for. Oh, that's the minimum emissive value. If I play with the right thing is good, but this is kind of what we're playing with right now. So let's say 1, we'll make it fully on or fully off. All right, so let's do that. So now we can do is we go back to the pillar shader, and we can now again this is multiply, but there's other things we can do. We can look at ramp. If I look at ramp or some kind of range, right? So I can clamp it between a value, right? A minimum and maximum, 1 minus a random range. This is kind of neat that I can do random ranges, or I can do remap, which is what we did before, right? So let's make it so that I can clamp it, right? I want to clamp it between 2 values. What does that clamp look like? So here's the min value and here's the maximum value. So 0 and 1. So that is different than a multiply. So I take away the multiply and I put the clamp in place instead. What does that do? So we want to put it inside of here. And we want to say that the minimum value is 0, but the normal map strength is 1. That's the max, right? So from 0 to 1. And then we can take that value and put that into the normal map. What does that give us when I save it? So save asset. Does that give us the effect we want? So again, that's 1, but what if I go to 0.1? That's what we're looking at. Look at that, 0.1. What if I go to 0.05, right? It changes the value of that thing. So you can see now that we have with the effect that we want. We can choose how high or how low, and it's going to clamp it to 1, but I can bring it down lower, right? It won't allow me to go negative. It'll turn either on or off, but it'll actually clamp the value, which is pretty cool. So more, I bring it down, so there's more crackly nature to it, but that is more of what we're looking for. So a ramp, some kind of clamping value. Again, minimum, max, right, where we have our maximum value in there. And again, you can choose to make this different if you like as well. Okay, cool. So that is something we want to try. So save that asset, and let's try that again one more time. So let's see what that looks like. So more is less. So if I go less here, it's going to be more crackly. If I go more as I move towards 1, it's going to be more of what we're expecting. It's kind of an inversion, isn't it? So it's like we're looking at a 1 minus is what we're looking at here instead. Let's try that. So remember that there's different ones we can try here, right? So one of them is a clamp, and the other one is a 1 minus. 1 minus basically says I want to take whatever this value is, and I want to subtract it from the final value. 1 minus this. to give me the effect that I want. So, you know, I can take this and put it in the way. I think it's this way. And then put it out to normal map. And let's see, or it might be the other way. Let's see how that looks. And I think if I was to go into one, it's kind of the same. It's not exact. Oh, wait, did we save it? Did we save it? We did not. Yes. So that means if I bring it up higher or go lower, it's not quite what I was looking for. It kind of gives me a really weird sheen effect. So it's probably going to be something before this. So here's my normal map strength. And it's like 1 minus this to produce whatever this is. 1 minus this from my tangent. That goes into there. And then it clamps it, minimum, maximum. Anyways, I'm just going to go directly in. I think that's for now what I want, but we'll figure out the 1 minus stuff later. So now that I've got this, I want to kind of surround this thing and right click and go into convert to, group selection. I'm going to call this the normal map channel. Again, we can always play with this, degroup it, all that stuff later on, but that is the normal map channel. Then I have a bunch of extra stuff, metallic, smoothness, and ambient occlusion. I do have an ambient occlusion texture for this. I don't have a smoothness. Let's do the one last texture. We'll do the ambient occlusion stuff. And I'll move the rim effect way out here. And so just like before, we'll just drag and drop. We'll do texture. And from there, we'll do a input, which is a texture. And we'll right click and we'll do a convert to property. We'll say that we'll rename this to AO texture. And we'll save the asset. And now we'll see that we'll have an AO texture down here. We can grab the AO texture and bring it in, right? So we can see what that looks like, ambient occlusion. We also have roughness and a height value. There's a height map and a roughness value. We've done a lot, right? So this is the AO texture that's in there, right? And the roughness is kind of like what the metallic is. It's kind of the opposite of metallic, where metallic should be really low. We don't have the metallic value or the smoothness. We can bring those out as floating point values. We'll say that this is a float, right? And we'll rename it. We'll call this, we'll convert this to a property, which we'll call the metallic, right? And we'll go smoothness. We'll put this out here as a float, and we'll make that also a property, which we'll call a, move this a little bit bigger, we'll call this the smoothness. Smoothness, roughness. Now, smoothness, what I can do is, depending on how rough or smooth it is, I can use this as a texture for sure if I didn't want this. So that could be one of my roughness can go in there. Same thing with metallic. Kind of metallic and smoothness make up a roughness, kind of. And one thing I can't do, notice that I can't, I can select stuff. It says I can select unused nodes. I can increase precision and stuff like that. I can also change the type. So right now it's using a smoothness metallic as opposed to specular. And if I had a specular map, I can have that instead. I can change this to be different than what it is. But now I got smoothness and metallic. And if I save my asset, I can certainly turn those down, those values. So right now it's 0, 0. I can make it so that it is, if I turn this up to 1, it becomes very, very kind of more shiny. That's what it does. So definitely want to keep that low. Metallic makes it, if I increase that value to 1, it kind of makes it so it's kind of a flat metallic absorption from how it absorbs light and stuff. So again, I don't want to make that metallic. If anything, it's going to be very low, a bit of metal in it and a bit of smoothness in it, but not too much to give it the right effect of what I want. And this, my friends, is my shader. Okay. So you can see that we did pretty good. We made our own shader network right here in Unity. One thing we can probably do is combine these two things together. And again, I can make them a little bit smaller so we can kind of compact these two things. And say this is the ambient channel. So group selection, ambient, occlusion channel. Right, so we can have that in there too. There we go. And we can save this. We can save the asset, right, as an example. We save all those things. And now we're good. We've got our little shader that we created here. And that pillar shader can be applied to any shader we want. We can also, later on, if we really want to, I can view the generated shader in code. I can copy the shader and make my own. So once I've done this, I can actually do some extra work and play with the shader in code, which is pretty cool. So I can have a pillar shader graph and then an actual shader output later on. In other words, like almost like compile it. All right, great. So this is fantastic. And if I go back to the game, you can see now that I have my full effect. And this is what I wanted to do today, right? So I kind of have my full effect. But it wouldn't be complete unless we did two things. We want to test this on the device, and we want to test it in our game scene. So now that we have this tested and we can run it, we can see that two things happen when we play the game. It looks like he's good, right? And it works behind him. That's nice. And now we want to do a couple things before we move on. I want to fix my shadows. So my shadows, we've noticed that they're pretty bad, right? Look at that shadow stuff, right? So shadow looks like it's terrible. How do I improve that shadow stuff? Well, it comes down to edit. This is before we go out to the device again. Edit, and if I go to project settings, then I can see here, take a look at these. I can see here that I have my graphic settings are set to this, but I have something called quality settings. So quality settings, by default right now for my Android device, we've set it to high. And it says full res, per texture, distance shadow masks, 2 bones, every V-blank, and that's what it is. But how come my shadows are so bad, right? Why does it look so bad? So what can I do to improve that? So we have quality, we have graphics. So those are the two things we've looked at. We also have our player settings, right? So we want to make sure that the player says 11A as opposed to what it did before. And then down in here inside of other settings, make sure that your package also says 11A, not 10A, because we're making a brand new one. There we go. That's 11A. So it doesn't seem there's much to do in here necessarily, right? So here we have our latest API and all that kind of stuff. I think we're pretty good there. So it's not in here. So where else can we look to make this better? Well, remember that URP asset thing? We have this pipeline asset, and this pipeline asset is one place we can look. It says that our anti-aliasing right now is disabled. We want to turn this from disabled to at least 2x. You can't see a difference here, but that's going to help us later on. HDR is definitely something we want. Depth texture, opaque texture, we're not going to turn that on. Per object limit, we want to make it 4 lights max. Maximum distance and metric, we can increase the value, this value here, and the number of cascades is important too. Let's move to something like what we have in our, if I go to, again, edit, and I go to my project settings, you can see that inside of my quality settings, we have the number of cascades we want to use. So right now, shadows is a distant shadow mask. We want to use that, but how many cascades do I want to use? If I look at Ultra, right, as an example, Ultra looks a lot more. We have 4 bones, and the level of detail bias is 2, and all that kind of stuff. What I want is at least 2. And by the way, the rendering pipeline isn't being turned on. Let's turn that rendering pipeline on. So I want to kind of select that and choose URP. So that's something I want to do, right? So URP, it's linked to URP now, this part. So some of these values are being overwritten now by my my shader. We know that this is the one we're going to use. Hi. Awesome. So let's leave this alone. Let's go back to this and change the level of detail cascade count to 2. So notice right away we get a lot better in here, right, than we had before. If we increase that more, we can go as high as 4, we can get a lot more detail in there, right? So again, notice that we're getting a lot more cleaner lines here, right? Be careful, guys. The more cascades you put in, the more memory for your little device, and it might be a little better. But 2 is definitely better than 1. So if I go back to the number of splits, that's how many cascades there are. Cascades are like, the closer we are to an object, we have a lot of detail. The farther we are from an object for the shadows, we have very bad detail, right? So that's something we want to include. So the number of splits is what we have. 4 is the max. Let's do something like 3, or even if I go to back to 2. So here's 2. 2 is looking pretty rough. But what if I was to take the light that's in the scene, the directional light, and right now we have directional shadows, and it says soft shadows. So that's something that we have, soft shadows. We're using the pipeline settings for this, right? Soft shadows. Okay, let's go back to that lighting. So lighting, here we go. And then what about into environment? So environment says it's skybox. The sun source, we haven't really chosen. Let's choose the sun source as this light. So you can see that the light that we've found in the skybox there. Let's also add in the skybox we had. Materials, let's go and put in the skybox material that we made, just to give it the same look and feel as we normally have in a scene. Again, this is in our test scene. We're looking here for quality settings. Okay, and I'm just working on the quality settings one by one. So environment, skybox, real-time shadow color is this, right? You can see that that's what that is. Source is the environment lighting is the skybox. You can also increase the intensity there if you want to. I'm not going to do that. Fog. Let's increase fog again to the same level, 0.04 or something like that. And then again, what this does is objects that are farther away are less detailed than the objects that are close up, right? So kind of cool. Very nice, but take a look at that. Still not quite great. Good enough, right? That we have in there. And that's our directional light. What about Crypto himself? Crypto, if you look at Crypto, and if I go to CH45, from an inspector perspective, it says that I have lighting is on, casting shadows, right? Here's our thing. It says 2 shadows, shadows only on. And then it talks about a bunch of stuff, right? So this is kind of the thing we want to look at here, right? So for, you know, we want to look here. We want to look at all the places we can. So the directional light is 1. So soft shadows for the directional light. It says real time or mixed. Let's click mixed. Mixed makes it a little bit better. We're going to have some areas that are soft and some areas that are not. Hard and soft shadows, what we're looking at, right? Some places. So this is kind of what we want for our lighting when we go back, right? Our main camera is also something we have to look at it. Now, notice that it says I have anti-aliasing on for my main camera. I can go to a fast approximation, or I can use my default pipeline, right? Let's go back to that. Again, I'm starting to look at the settings is what I'm doing here, right? To optimize what this looks like, okay? Using pipeline settings for these, right? And it says my environment, my background is my skybox. That's fine. I like those kind of things. What other options do I have? Here's my stack. If I want to stack different things, I can put in there, different effects. And, you know, kind of looking down the line here about anything else. Anti-aliasing, I can do a fast approximation. But again, once we start doing high anti-aliasing, it really reduces our performance. So keep an eye on this one. What type of camera is it? And the render type is base or an overlay. We want to do a base. So all of those are good. So lighting is good. We've done soft shadows. It's a directional light. You can choose different kinds of light, right? Render mode is auto. I can make it important. If I made it important, then it'll be always on. Sometimes I need to do that for some spotlights and those kind of things, right? And real-time shadows, here's the strength, and I can use pipeline settings or custom settings. We sort of kind of covered almost everything. And then we went to, the material settings. Let's take a look at his materials. So if I go to his materials, so again, under materials folder, if I look at crypto himself, you can see that he's got some materials in here and it says render queue from shader. So kind of interesting, right? So we've kind of gone through the whole gamut of things. So again, let's look at the settings. So again, under edit, all the settings are under project settings, right? And we started with the universal render pipeline, right? And we looked at high as the quality level, okay? And then we looked at the graphic settings. Graphic settings are just kind of hitting the same settings, from the pipeline settings. So that's just pointing to the pipeline settings there, right? So same kind of stuff there. So those are two. And then in the URP assets, there's two. There's this one and this one, okay? So it says, so one thing that you can also see here is that it says transparent receive shadows, overrides a stencil, opaque layer mask can select things that are opaque or not, and transparent layer mask can select things that we want to have transparencies on. This also helps us with some performance issues, right? But the one we really want to look at is this one. And this is where we can decide whether we want HDR or not. So what does that look like? So HDR is obviously brighter colors, and things will pop. Render scale, we want a main light. Main light is per pixel. We can also do, what we want to do here, as well as if I want to cast shadows or not. What's my shadow resolution? Right now it's pretty good, 2048, right? And when it comes to extra lights, what does that look like? We can kind of close these off to make it easy. Shadows, this is another thing. Shadow distance. If I click on soft shadows now, let's take a look. So I've kind of opened this up, and if I click just soft shadows, it hides the problem. So this kind of blurs the shadow effect. Again, we only have 2 cascades. Hell, even if I went to 1 cascade, take a look at that. 1 cascade makes it look a little bit too thin, right? 2 cascades makes it look a lot more realistic. 3 cascades makes it really much more defined, almost too defined, right? So it looks like it's going to be like 2 cascades with a bit of blurring, and that's kind of pretty good. And that'll do the shadow. It'll give us a sense of shape, and it won't be as dithered. It won't be as dithered, but it won't be as straight as this one, right? So straight objects like walls, no problem, but objects that are irregularly shaped like this one will still get a shadow. That's what 2 cascades mean. Once I go to 3 cascades, it becomes very sharp. Okay, just be careful of this. However, I can also change the maximum distance. If I go to 10, you can see that there's going to be some areas that are sharp and some areas that are hazy, and that's depending on the distance of the shadows. The bigger the distance, let's say, for example, I made this 200, you're going to see that the distance is going to make this all hazy, right? And the number we had before was 50, which seems to be the right number. Okay, so 3 could possibly be something we do, and you can see the split. 5 meters, within 5 meters, it's perfect quality. So amazing quality. Within 10 meters, it's like, level of detail number 2. And within 35 meters, that's level of detail number 3. So anything greater than 35 meters. And that's like the distance between your camera and the player. Please be careful. The more of these you add, and even this, what we've added down here, if I take this away, you can see the difference between adding in soft shadows and taking it away, and what the effect that has on the scene. Post-processing. If I wanted to use high dynamic range, what does that look like? It makes it so that it, again, if we were going to have a post-processing effect, it would pop, but it says high dynamic range color grading mode works best on platforms that support floating point textures. And Our platform does not. So let's go to LDR instead. All right, and that's the best we can probably do with our shadows. And we did this all in the test scene before we even went to the device. Why? Because it makes sense. So if I go back and I try it out again, what does it look like? It looks like this. A much better view. All right, again, a bit of blurring over here, tight shadows over here, which is kind of more realistic. We got a fog going on, a lot of little effects happening, and it looks really great now. All right, so let's take this back into the main scene. So file, save project. Let's take it back into the main scene. And let's do it. Let's auto-generate it and see what it looks like. Cool. So it kind of looks a lot darker than before, right? And as we get closer, let's see if we can get closer to our enemies, right? There we go. This guy found us. He's coming. He seems to be pretty dark or pretty faded out, but as he comes closer, he becomes more, again, resolved, and his body looks way better than he did before. Look at that. Look at his shader. Why? We're using URP. URP adds a lot of really great resolution and some great highlights and so on. So that's what it looks like there. All right, you can see that that looks really amazing. How does this turn out on the device? Does it even work on the device? Let's try that next. So file, save project, and let us file, build, and run, and let's build on the device. And what we want to see is there's two things I want to see, right? One, how does it look on the device itself? And the second thing is, how do I build? If I put my pillar in the scene now, right, which I don't have anywhere, how does that pillar look? Does that custom shader that we made, does it work, right, or not? Again, I'm going to spark out here as it's building, so I'll take a drink of this like nice juice my wife gave me. Cheers. Very nice. It's like a mango. It's not going to talk as much because I'm going to spark out and sound like a robot. That is really strange. That's bizarre. I can't get that visor thing. It's like it's pointing at a monitor that doesn't exist. All right, let's open it up and give it a try. And what does it look like now? Do I see everything here? I do. One thing is that this texture here looks pretty bad, and it'd be nice if we had nicer ones. It's kind of a dull color, but right now we're not going to modify anything. But you can see that it looks pretty good, right? And let's see if they actually run. Performance-wise, I'm pretty happy with the performance, at least in the emulator. And you can see the details of the graphic that we got there, so that's pretty good. And this guy's like right on me. That's why it looks the way it does. And I'm kind of sparked out. It looks like I can't move. So that's interesting. All right, so that's pretty cool. That all worked out nice. Let's add a pillar to the scene as well. So if I take the resources prefabs, and if I grab a pillar, let's put that in the scene. And this time what we'll do is, for this pillar, we'll change the material from stone wall. We'll change to pillar material. And this will be that glowy material that we'll see. And we'll put the pillar in place here. One thing, in order for us to, since the pillar is going to be placed in the scene, right, it's not going to have a value. So one thing we need to do is put it inside the level. Even though it's physically here in the start tile, it's got to be in the level for it to be something that is considered. Start tile is ground. Pillar is also going to be of type ground. And we should be able to see it here in the level while we build it. So if I build this up locally, then if I look in the scene itself, and notice the fog, right? Fog is really great. It helps us in performance. If I click on scene, it did the pillar thing. Looks like it's working, right? So this is my game. And if I turn, there's the pillar. You can see it's pulsing, just like before, and it's in the game. Awesome. That's what I want. Now let's see if it works on the device. So File, Build and Run. And does it work on the emulator? And to make it stylized, we can put 4 of these things, one in each corner, right? And we could have randomized the values, so kind of a random start, right? Again, you can play with that shader and create all kinds of little cool effects. Right now, everything's going to glow at the same time because it's going to follow along. If I had more than one of these things, it would glow all together at the same and see what it looks like. So here's Unity launching, and if we turn over, then we should see our pillar glowing. Yay. Awesome. And we see the details. If I go closer to it, we can see that it's got that normal map happening. It looks pretty good, and it looks like it's glowing exactly how we want. A little bit too bright, in my opinion, but that's just the way it is. Great. So now, one more thing. What if we had 4 of these things, and we put them at each corner? So we say, okay, well, I want this pillar. And we'll put pillar there, you know, kind of stuff. And we'll use a little bit of our eye to look at that. So look at our level. Here's our pillar. And let's take a look at the position on the x-axis. Let's make it exactly 5. And we'll make on the z-axis 5. And then we'll duplicate it, Control D. And we'll move that to the other side over here. So this is -5. Like almost like a little area when we start off. So it's not completely blank or empty the way it was. And gives a little bit of shadow. And again, I will do Control D. And move this over here like so. And this will be -5. And then we'll Control D. And we'll move this one over here like so. So move this at 5. There we go. So we got our little character goes in the middle, and he has these 4 glowing pillars. This is kind of our start area, which is kind of cool. And let's see how that looks. So we look, we can see their pillar. It gives us a little bit more of a look and feel to it. We know that this is our start area, and this is great. Good. Now let's move this to File, Build and Run, and that'll be our final build. So for your Lab 11, what I'm looking for is, can you show me the glowing pillars? That's one screenshot. I wouldn't mind also taking a look at your pillar shader. So show me the pillar shader network, even if you did exactly what I did, or if you played around with it. There's some great resources out there. And I'm going to show you a link to that in a second before we go. So why am I showing you all this stuff? Because you can make your game really pop with little effects like this. And there's a ton of other effects you can make that are awesome inside of using Shader Graph. Okay, so that totally looks great. Look at that. So a few different things there. Makes it more interesting than what we had before. Still very performant, but they're going to glow at the exact same time. Why? Because that's the way we kind of made it together. We could make it so that they glow at different times, and especially this side looks really flat, right? But you know, these are things that we kind of put together, and we can change the color if we don't like that color. We want one of them to be orange, another one to be red, and another one to be green. We can do that because we have control over the shader, right? So again, what I mean by that is in the game, just like anything else, if I grab one of them, let's say grab this one, and if I wanted to duplicate the shader, the pillar material, let's say as an example, and I made one that was a red pillar material, another one that was a green pillar material, as long as they point to the same shader, you're golden. You can have different effects, different color values, different glowing. And in fact, we can add other controls that can make this pulse quicker and slower and a bunch of other stuff in there, as well as adding noise, a lot of stuff. So that is your lab 11. So this is the last lab of the semester. I wanted to point this out to you. Let's put this up on GitHub. File, save, files, save project. Again, I'd want a shot of your game running in the emulator, maybe a shot of your shader network, a little bit closer up, something that looks maybe like this, where I can see your kind of your effects that you put into place together, similar to what I've kind of shown you. So you can show that off, right? You know, that's kind of something that you want to take a picture of there, which is neat. And yeah, I mean, that's pretty good. Let's file, save project, and exit. And we'll put this up on GitHub. And it says, your change will be lost if you don't save them. Save. Let it do its thing. And I'll also turn off the emulator right now because we don't need that. And we'll turn this off. And then we'll go into our files here and take a look. So we'll say git add dot, git commit -m, and we'll say added pillar shader. And then git push. And so that's not just pillar shader, that's also converting our project to the universal render pipeline, converting our shaders. All those things is the things that we mentioned here in our in the things that we would do in our lab today, which is all these things. Okay, we also simplified our animation. We did that today, but a couple of notes before we go. One is, remember that next week is your final presentation week, which means that's the time by the end of Friday of next week, Friday, April the 16th, that's when everything is due, all your stuff. If you need help from me one-on-one, please engage me before then. I'd like to be able to help you with that. One more thing is, there are numerous amounts of resources out there to create shader graphs. So if I did something like Unity shader graph, if I just looked that up, the main one you want to go to is unity.com shader graph. And this link right here, which I'll put up on eCentennial for you. So this will be under here, new link. It has a pile of resources here that I would like to share with you. One of them is, if you follow along, it talks about amazing little effects you can do with your shader graph, such as different kinds of outlines, highlights. You can do things with, you know, some parts of it being opaque, some parts of it being occluded, you know, those kind of things. You can change different kinds of patterns that you want to apply to your surface shader. You can create different effects, like some kind of distortion, some kind of displacement shader to create clouds, volumetric clouds, and those kind of things, as well as explosions. They even have things like making portals, how to do that, and there's some great little tips and tricks and tutorials on how to do all this stuff. I fully encourage you to take a look, walk through some of these if you're interested. If you're someone who loves to make your own little effects, again, it'll make the difference between a good game and a great looking game, right? So that combined with VFX graph, which is the other thing. So I looked at VFX graph. Again, this is something that you need the URP for. VFX graph combined with shader graph Again, it's using kind of a shader network or some equivalent of a node network that can create different kind of particle effects. So really cool stuff. If you combine those two things together, you have an amazing set of tools that you can make your game look incredible with no code, really, at the end of the day. Okay, very no code or low code. All right, questions around this before we go for the day. So that's VFX graph. I'll add that into our collection. All right, guys. Well, if there's no other questions, good luck on your submission tonight. Again, if you need my help, please hit me up. I'll try and help you with whatever you can. I'm here all night until midnight if you need me, and I'll be available for you guys throughout the rest of the week for your final submission as well as for your final presentation. Otherwise, that's it for me, guys. I'm going to stop recording this now, and I'll go to the people that are physically here in class. Let's just go back to the title screen. All right. Anybody have questions?